All right. Good afternoon and welcome to day 4 of Blockchain Community Day 2025. Today's theme is building and scaling, diving into how to create robust, secure, and scalable blockchain solutions for real-world impact. Before we dive in, don't forget to join our live quests and quizzes. Participate to win Netflix subscriptions, Spotify Premium, Amazon gift cards, and many more. We've really already have a happy winner in the chat, so congratulations. And here's a challenge. We've hidden secret words in the presentation slides for day 1, 2, and 3. Be the first one to find them and claim your reward. Already. Kicking off day 4, please welcome Andranik Chorokhyan and Andrei Shulaev, experts in blockchain infrastructure and performance. Their talk, Building and Scaling Private Blockchain Performance, will offer practical insights in deploying and optimizing private Ethereum blockchains with Bisu client. Very welcome on the stage. Happy to see you here, guys.
Thank you. Right, shall we begin? I welcome everyone. Today we'll discuss the private blockchain with some focus on the performance. My name is Shulaev Andrei. I'm a solution architect at EPAM, having about 10 years experience in IT. Today's talk will consist of 2 parts. The first one, I'll be introducing private blockchain. We'll look at what they are, why organizations use them, and how they actually work, with particular focus on the performance challenges and limitations. And then my colleague Andranik will take a look and over the second part, where we will dive into particular side of things, specifically how we approach in conduct performance testing and real world scenarios. By the end of the talk, I hope you're going to have a clear understanding of both theory behind the private blockchain and the particular steps involved in evaluating their performance. Here is the quick look of what I will cover in this session. First, we'll define what exactly the private blockchain is and how it's different from public one. And next, we'll explore some use cases where private blockchain offer unique values. We'll also focus on important factors enterprises should consider when selecting the private blockchain client. And finally, we will look at how the real-world use cases of public and private blockchains stack up against each other. Let's dive in. Private blockchain have a few defining characteristics. First, they operate within controlled and permission access, meaning only invited participants can join the network and perform transactions. And second, private blockchain offer customizable privacy and security, so organization can tailor these settings to fit their unique requirements. They are commonly used in enterprise environments or consortiums where multiple organizations work together but still require privacy and control, which means private blockchain are typically owned or controlled by a single entity or defined group of entities, providing centralized governance over the network. When we compare public and private blockchain, a few differences stand out. First, access. Public blockchain like Bitcoin or Ethereum are open to anyone. Anyone can join the blockchain and there is no restriction or participating. Governments is also different. Public chain are fully decentralized, where a private blockchain have a government structure controlled by a single organization or a consortium. In terms of consensus mechanism, public network typically use mechanism like proof of work or proof of stake, and private blockchain often use more efficient protocol like QBFT or IBFT. We're going to dive in details a bit later about this. And this is only the most typical and more common the mechanism. There's plenty more. And finally, performance. Public blockchain tends to be slower. You might think about 15 TPS, like in some very popular networks per seconds, while private blockchain can reach hundreds or even thousands of transactions per second due to their optimization and restricted access. To maintain an accurate and trusted ledger, blockchain rely on what is called consensus mechanism, and this is basically the process which system use to make sure all the participants agree on the state of the data. In public blockchain, proof of work or proof of stake are the most commonly used methods. These focus on the decentralization and security, but sometimes at the cost of the performance. The private blockchain, on our hand, typically use proof of authority, and since access is limited to trusted participants, proof of authority allows for faster and more efficient consensus while still ensuring the data integrity. Here we can see the table with some comparison between those most popular mechanisms. For example, proof of work relies on computational effort. Anyone with the right hardware can participate by solving complex puzzles. This approach is quite secure, but it's also slow and sometimes energy intensive. Proof of stake select validators based on the number of tokens they hold and are willing to stake. This method is faster than proof of work and still maintains strong security, but introducing economic penalties for malicious behavior. And proof of work replace computational work and token holding with identity and reputation. Only approved authorities can validate transaction, resulting in a best performance. However, the security of the network depends heavily on the honesty and integrity of these few trusted authorities. And each mechanism obviously has some strength and trade-offs in terms of speed, openness, and security. Yeah. While selecting the private blockchain clients for the organization, there are a couple crucial factors we need to consider. First, is it secure in privacy, and security in privacy uh, is implemented well enough in this particular client. Next, in scalability and performance, can the system handle increasing numbers of users and transactions? We need to grow with the good performance. Integration with the existing IT infrastructure, meaning how well we can use this client within existing landscape with the toolset, technologies, machines, wherever it is. And also quite important is the community support and how quick we can get support from them and get some feature or maintenance delivered if we need them. And finally, we need to make sure all of those four above mentioned criteria do not contradict the requirements coming from the business. Evaluating those points carefully will help ensure our blockchain project will succeed. Here are quite simplified decision tree for the particular use case we had with one of our clients. We were making decision on the blockchain client. And first of all, we need to ask ourselves, do we actually need a blockchain? If no, we might be lucky. If yes, then we need to ask the next question, should it be deployed on premise or not? If no, then we probably might use some public blockchain or use blockchain as a service. There are plenty of offering on the market. If we need to use a blockchain, then we need to ask ourselves, should be EVM compatible? Because probably want to deploy some smart contracts, for example, or use the tools which already exist in the landscape. No, there are so many of our clients we can use which are quite performant. If we need to use the EVM compatibility, then we need to ask ourselves, do we ready to sacrifice the security and permissioning, for example, for the performance? If we ready to do it, we could use GEF client. If no, we need to ask ourselves the final question on this tree: is it actively maintained and supported? And here we basically do options, quorum, which is kind of stale standard for the private blockchains, and the Bezo, which is currently widely used for the private blockchain deployment within the enterprise landscape. Here again, we table where we might compare the key features of those three clients, the crucial components for us here are the support for the community and is it Ethereum interoperable. The other parameters is kind of similar, and also the language might be the crucial here, because if we want to implement some additional feature to the clients, we might want to use the typical language which we use on the project. In this particular case, it is a Java language. Which leads us to the Spotlight Harbor Ledger Bezo, which might sound not so fancy, but yet it's good old open source Java-based framework and could run both permission and public networks, which means we might get the feature delivered from the public blockchain from Ethereum delivered quite quickly. Those are about security or performance. And the feature of the Bezo, main feature are permissioning, privacy. It has a very rich API, fully supporting Ethereum API with some additional one, very well documented. And also it has a modular consensus. We could choose what we need, and also we can implement our own if we need to do so. And also plugin support, which allows to customize the client even more granular. For example, restrict deployment of the contract only to particular accounts. And also it's compatible with all the other Ethereum tools, just as mentioned. And all it looks good until they're coming the new requirement from the client that this blockchain should be publicly accessible, which leads us to the strange situation. While we're calling something as a private blockchain, but yet having so many features for the public blockchain. And here we need to call it more like a hybrid blockchain, which is very common for the organization and the projects like we have right now. In many real-world scenarios, organizations find that neither fully private or not fully public blockchain alone can meet all of the needs. And that's why this hybrid blockchain comes in, combining the control and security and privacy of private blockchain with transparency and openness and decentralization benefits from public blockchain. Which again leads us to the question, if we open to the public, can we handle all of those traffic coming from all sources of the internet? If it's restricted access and only known entities can participate in the network, it's quite simple to say and assume that, yeah, we can handle those 10 transactions per second. But once we become kind of public blockchain, can we handle the performance issues? And from the theoretical perspective, which you just mentioned, the public blockchain usually are decentralized, they are highly secure, and they're slow because of the consensus mechanism they use. On the other hand, private blockchain, they have fewer nodes, they are permissioned, they are fast because they're optimized because of the consensus mechanism again. And as gonna see later to the second part of presentation, we actually can get pretty good transaction per second ratio close to the 3K. And also kind of justify the presentation that we're having today, we were doing quite extensive performance testing, and while facing some issues with it, we were trying to reach out to the core developers of the Bezo. And that's the answer we got from them about the setup we were using, that no one before us apparently were doing the performance testing on the scale that we were doing. Here they're saying like they only tested for the ERC20 contract minting, they only tested it below 1K TPS. Yeah, that's it. I hope you have a good setting for the second part presentation, which Andranik will dive in and share more practical things which we met doing those performance testing and optimizations. Thank you.
Hello. Yeah, let me try to share my screen. Hope you see that. Oops, sorry. Let me share the entire screen, otherwise maybe that can be an issue. Okay. Hello again. I'm Andranik. I will continue the more practical testing-related, performance testing-related part of what Andrei started to talk about. All in all, I have 12 years of experience in quality engineering. I also work at EPAM. I'll start from the tooling. Actually, as we were starting the performance testing, we needed to choose the appropriate tool for that. Of course, we started analysis, we started some investigation among different commonly used tools and some famous ones. However, we reached to agreement at the end to use the Caliper, which is a kind of benchmarking standard tool for the Hyperledger under the Hyperledger umbrella as the part of the overall solution, and also due to a couple of different benefits that Caliper provided at that moment. I'll speak about that. The pros and cons that we analyzed, right? And for some of them, actually, we faced during the process of the work. So I'll start from the pros. One of the best, let's say, benefits that Caliper suggests is the automatic nonce management, which can be a real headache if one tries to do in blockchain environment without knowing much about that. Second one, as I've already stated, it is under the same like platform umbrella. It is Hyperledger, and we could get some support, we could get documentation, etc. Then for the initial start, it was easy to set up, and of course, it supported multi-worker support, multi-worker option, which gives us a possibility to distribute the load generator not from one machine but from different nodes machines. Of course, Caliper has drawbacks as well, so it is not news. The connection management is the worst ever, I noticed, but it is a problem that can be easily solved, and we did it. Retry mechanism is not implemented, unfortunately, and I hope that in the future releases it will be there. But at this moment, if the request of the transaction is failing, Caliper doesn't have a possibility to retry that. And some issues with the multi-account management. I won't dive into the details at the moment. The testing types. Though this is blockchain, the from the performance testing perspective, the testing types are pretty common ones. In the interest of time, I will not define all of them because I'm sure that the audience listening this are pretty aware of those types. So those are load test, stress, spike, and endurance. The test types that we performed during our implementation and experiments. I will focus on this slide actually a bit more because, you know, some time back I was living without blockchain. That was easy time and happy timing. So I sometimes joke that saying that my life was split into two phases, before blockchain and after that. So it appeared that some kind of concepts or approaches that we used to know from the Web2 world, especially from the performance point of view, sometimes those like concepts at least do not work as such in Web3 and in blockchain. I just brought a couple of examples, right? One of the examples, horizontal scaling. So we all know that if we scale horizontally, we add nodes, we add more physical devices. It should bring to increase of the performance, right? At least not decrease, let's say that way. But it appeared that in private blockchain, it is not true. When we increase the number of validators, the number of physical devices, the the road among all those validators is becoming more complicated. So more connected peers appear at the end, and we have not just stable or not increasing performance, but vice versa. We are having a decrease of the performance. Another interesting nuance is that increasing of the number of the physical accounts participating in the transactions during the performance test, it appeared that this also brings to damage of the performance, and performance goes down due to this, which was also strange. As I've initially stated, the nonce management is a big headache, and this is a real challenge in this blockchain world. So this is another challenge. And one more thing which I didn't mention here, but worth highlighting actually, is that our key indicator or metric is still the TPS, right? Transaction per second. However, the transaction per second in blockchain and out of the blockchain are kind of a bit different things, because in blockchain, transaction is not just one request to the server, right? Like we used to understand in the Web 2. It is at least two requests. So one request to get the nonce, and second request is to send the real transaction. I'm not even speaking about the signing of the transaction, which is also like as an addition, right? So TPS understanding is also a bit different in blockchain world. Throughput. I'll speak about this right column at the moment, the throughput that we reached. In the end, Andrei mentioned that we got a kind of message and we read even in different places in internet that TPS more than 1000, it is already kind of too challenging and too big, and usually people do not even try to reach this kind of TPS. However, we did due to our requirements from the customer. So we managed to reach to 1700 up to 2200 TPS as a baseline. While this like range, because depending on different parameters and configurations, this number can differ. But in general, it is closer to 2K, right? And we also kept a spike up to 3K during 1 minute period without crashing, without restarting, etc. I won't dive into the details of this left hand column, the key parameters. Just for your information, that those 6 are not the so we played around not only with these 6 parameters during our experiments of performance, but the number of parameters were close to 20. They were hardware parameters, blockchain PESU parameters, network related, etc. However, I listed here the 6 the most important, the crucial parameters that mostly affect the performance. And at the end, I want to highlight some sort of recommendations for the people who previously didn't work with blockchain, but they do want to do that, or they have to do that. And from the performance perspective, if you guys want to reach to performance TPS more than 1000, really, then you should know that the RPC nodes, I'm not speaking about the validator nodes, the nodes that are RPC, that are exposed to the external world. However, they are receiving transactions requests, but they are not validating requests. So RPC nodes amount should be more than 2, definitely. Otherwise, RPC will be a bottleneck for sure. So in our case, it was 3 to 4, and that was enough. The block period should be as low as possible. So from 1 to 2 seconds, if that's possible, because if it is more, then it will bring to issue in reaching higher throughput. If the block period is small enough, for example, 1 second or 2 seconds, right? Then definitely we will have another bottleneck. In this case, it will be mempool or transaction pool and the block size or gas limit per block, right? So those 2 parameters should be big enough to not serve as a bottleneck in this whole operation chain. Otherwise, your blockchain will manage to successfully handle all the transactions that are received. However, the block size and the transaction pool will become a bottleneck. So they will not go farther to that. And of course, the CPU and frequency of the CPU, this is pretty important. So this is based on my humble experience that yeah, we did for our customer, and we understood all those details. Thank you. That's it from me. My contacts, in case you have any question, feel free to reach out to me. Thank you.
Guys, thank you so much. I think we can take a couple questions from the audience. They will be projected on the screen.
Well, it hardly depends on the use case we're going to have from our system. In principle, since we are very flexible and define where and how and why we want to integrate, we might do whatever. Like we could integrate with some standard services like Fireblocks. We might, depending on the client requirement, integrate some other blockchains and keep until this moment our blockchain semi-closed. But then again, depending on the client requirement, we might start slowly open the blockchain. So I would say in terms of configuration and integrations, we are very flexible, and it's all coming from the client requirements, basically. How it might affect performance, it's another point to test, but in general, in terms of kind of transactions, performances, it very much depends per integration. For example, for the Fireblocks, we might just provide for them additional Hive node, which shouldn't affect the overall performance of the blockchain. They will just effectively utilize one particular machine. So again, it's a very broad question. There is no good answer, I guess. Thank you. Again, coming from the requirements, I guess. Outperform in terms of the performance, hard to tell. Like there are some networks like Ton, for example, which claim have a very decent performance. But it's again coming from the perspective, if we need to keep something in secret from the public audience, if we need to, then public blockchain outperform. If we can use just some public one, then just not, why not use the, I don't know, hardware capacities from the public audience? We can just deploy the transaction to the public visibility and call it a day. It's kind of a similar question, I guess. Well, in terms of the enterprise, we consider it like another tool and just like another maybe database or another ledger. And just for the sake of simplicity and not to spend our time and labor for something which is already implemented by very clever people and is publicly available as an open source project. Why not use something which is there, like, I don't know, for checking something, for the supply chain management, etc. I would say just another program. There is much less philosophy about it, just pure utility. Well, that's a tricky and fun question. In terms of backups, every particular node of blockchain in principle should have all the data which every other node have. So it's not a problem to restore the blockchain state of the blockchain, but the tricky part comes when we define who can validate a transaction, because as we mentioned, the validators is not dynamically changed, they are defined somewhere on the blockchain level. In terms of Bezo, how it's been implemented, we do need to define it on the Genesis file. This is the file which we create on the very beginning of the blockchain, or we need to call the API methods, and all the validators should be alive at the moment when the blockchain is still operable. That it might happen that all the validators suddenly, I know, the electricity cable is cut off and there is no validator to validate those requests to propagate someone to be validator or disqualify them. And in this case, in Bezu, again, why it's quite good for the enterprises, that offers some solution for the disaster recovery in case we need to backup for the unknown region where there's no validators. There are some nuances in why we decided to do it in that way, mostly about the performance again. But in principle, it's possible with some manual or automated configuration on top of the client, we can effectively migrate temporary to another region and kind of seemingly restore the validator to our region, and once everything looks good on the original region, to just come back. So blockchain, we kind of utilizing features of the blockchain and some additional coming from the understanding that the Bezo is mostly used for the enterprises. Thanks.
All right, guys. Unfortunately, we ran out of the questions and the time. Huge thank you, Andranik and Andrei, for unpacking the real challenges of enterprise blockchain performance. Your recommendations, insights on bottlenecks and horizontal scaling limits, it was gold, guys. Thank you. You are very welcome back on our stage for another monthly basis calls we have. Yeah, thank you so much, guys. You have a great one.
Thank you.
Thanks for having us. Bye.
All right. Coming up next, we have Alexandr Shukhotskiy with his talk, Building Nation Scale Blockchains. And yeah, guys, stay tuned. We'll be right back and participate in the challenges on our Telegram. See you. Okay, up next, we have Alexandr Shukhotskiy, Delivery Manager at EPAM. And if you're a builder, architect, or a visionary looking to understand how to design blockchain infrastructures that are scalable and secure enough to serve millions, this talk is for you. Welcome on stage, Alexandr.
Thank you, Farooq. Hello, everyone. I hope you're all doing marvelously well. I'm excited to join this awesome event as one of the speakers. And today I'm going to share my experience building a central bank digital currency for one of the countries, which name I unfortunately cannot reveal because of NDA. But anyway, in one of my previous jobs, I served as a head of engineering for CBDC development project. This means that I was there from the proof of concept stage to a pilot-ready system. And during various stages of this project, I played several roles based off its needs. So I was a solution architect, a principal engineer, an engineering manager. So I built a team to move this project forward. And that means that I have a comprehensive perspective on various aspects. This project, this product evolved constantly, sometimes because of political regulations, sometimes because of technical drawbacks and so on. And this led to me and my team rebuilding the solution multiple times over the year. So in the end, it was like multiple proof of concepts, at least 2 MVPs before we reached a pilot stage. So I'm going to share some lessons that I've learned along the way. I believe these will be interesting, insightful. So here we go. So what is CBDC? Let me start with some fundamentals. So CBDC, an acronym or abbreviation for central bank digital currency. It's not a cryptocurrency. It's just a digital form of fiat money, usually issued by some governmental entity or central bank, and it's backed one-to-one by real money. CBDCs don't have to rely on blockchain at all because digital doesn't mean decentralized or blockchain driven. So if we talk about known CBDC projects across the world, then some of those are just a system relying on traditional data storage, perhaps relational database or NoSQL, because it's quite difficult to accomplish the goals that I will talk about later when relying on blockchain. Also, what I want to say next. Let me see. So CBDCs are usually, I would even say always, not mineable. They're not tradable. Also, CBDCs don't operate on public chains. Usually it's something permission-based, private networks. And also there are different models, retail versus wholesale. Like retail CBDCs can be used by individuals as well as businesses. Wholesale CBDCs usually are here just to allow for some interbank money transfers, something like that. Also, some CBDCs allow for dynamic conversion, like when you trade 1 unit of fiat currency to get 1 CBDC coin. And also CBDCs can be managed by banks that usually form digital funds to back it up. So speaking of technology foundations, as I mentioned, CBDCs that are driven by blockchains are usually permissioned, not public. So we are falling into the realm of something similar to Hyperledger, Corda, etc. And when you have to pick a technology to rely on, then you're very, very likely want it to be open source. Why? Because open source means cost-effective, transparent, auditable. You gain huge community support because usually when we talk about CBDCs, it means that the main entity behind it is something like government. So it's usually B2G customers. And those entities cannot allow for hiring expensive teams. Also, sometimes only people from specific countries with specific passports can be hired because it's like very sensitive. Usually governments care about not having any leaks. So it's quite complicated. And when you rely on open source, that also means that you have almost free access to the brightest minds in the industry that otherwise you won't be able to have on your team. So let me continue. So for this particular CBDC project that I'm speaking about, IBM Hyperledger Fabric was selected as the primary blockchain technology. And now I want to talk about some trade-offs. So when you want to develop a nation-scale blockchain-driven payment system, you usually want it to be both high trust and high performance. However, there is always a trade-off between the trust and the speed, the performance, call it whatever you like. Because if you want your system to be high trust, that means that you have to put all the logic, almost all the logic, at least the most crucial one, into smart contracts so that it's on chain. And you cannot have it, let's say, as gateway layer or anything surrounding your blockchain, because otherwise you can compromise data whichever you like. So let's imagine you have your logic in some microservice, and all that you have on chain is just recording it, storing it in the ledger. That means that participants of such blockchain systems cannot verify whether data was manipulated. It's just save and store it, nothing else. So it's better to move the logic on chain. In that case, the system will be higher trust, and also there will be such thing as endorsement policy, consensus. I will speak about later. But on the other hand, when you place more logic into smart contracts, the performance may decline, because usually it means that you will have quite a few disk input-output operations. Also, since the nodes of the blockchain system communicate with each other to reach consensus, it means multiple calls. So it will cause bigger latency, higher latency, and the system will be less performant. Also, I want to say a few words regarding endorsement policy patterns. So concerning IBM Hyperledger Fabric, it's configurable, and usually it's either the majority or some combination of supervisor peer plus any number of regular member peers. And the more nodes, the more peers are required for endorsement policy, for consensus. The slower is the system, but the more trustable it is. So, elaborating on what I previously said, when the teams that don't have much experience with CBDCs develop something like CBDC for a given country, they may default to widely used architectural patterns, principles, and so on, treating smart contracts as microservices that would be split by domain. So let's say wallet microservice, payment microservice, something like that. And this could result in multiple smart contracts creation. Also, I want to share with you another term that is used mostly when referring to IBM Hyperledger Fabric smart contracts. This term is chain code. So chain code is a piece of code that is deployed to the Hyperledger network, that stores some logic, that has access to the ledger, to the blockchain, and so on. So when the teams adopt something similar to microservice approach, they create multiple chain codes, deploy those to the network, and then experience some significant performance drawbacks, because when chain codes communicate with each other, those calls should just be multiplied by the number of peers that is needed to reach the consensus and that is needed for endorsement policy to be successfully applied. That's why it's better to have a single monolithic smart contract or chain code that will have access to all the data. And if there is a need to have granular smart contracts or to allow participants of the chain to deploy customly developed smart contracts, then you have to consider something like creating your own language or defining those contracts, maybe something JSON based that could be stored in the chain. Then it could be read by monolithic chain code, and the logic could be executed by this monolithic contract. However, microservice approach can still be applied and be used to great success if we speak about the transport layer. So microservices are great for developing and deploying some micro gateways that will be running on the nodes of CBDC system participants, because these could allow for greater flexibility and I would say more effective security control, because CBDCs can have participants among different institutions that would require custom tailoring their permissions. So you can have one regulator or a supervisor that should have like master access to the system, and you may have other participants like regular banks that should be able to execute only limited range of operations. In this case, you can deploy certain microservices to certain servers belonging to particular members of the system, and you can deploy everything to supervisor servers. So usually microservices are there just for some form of orchestration and usually act as just proxies. So let's say a mobile banking app can send a request to the corresponding bank infrastructure, and there you may have a microservice that would then use some crypto materials to connect to a chain code running on one of the peers of CBDC network. Okay, so let's move on. When developing components that would be running on chain, it's important to keep in mind that the code must be absolutely deterministic, because the code is being executed on multiple peers. Those peers could have slightly different timestamps when it's going to code executions, and this may lead to discrepancies which would result in aborting the operation. So it's better to never use something like, if we speak about Go programming language, something like time.now. And usually technologies such as IBM Hyperledger Fabric have their own safe functions to rely on when you need to get dates and times. Also, when speaking of randomization, let's say there's a need to generate random identifier to act as account ID or wallet ID. It's also required, absolutely required, to rely on seeded randomization, because if endorsement policy is applied and there are multiple peers required to reach consensus, then each peer will randomize its own value, and there will be discrepancies again that would make transaction obsolete. So speaking of programming language of choice, I have experience with Golang. Why? Because it's pretty lightweight, pretty performant, and what's even more important, it's a native programming language that of IBM Hyperledger Fabric. So it would allow for smooth integration. All you have to do is just import Hyperledger SDK package, and then you can communicate with your chain codes and so on. So what else I want to mention is that it's better not to have any external calls from chain codes or from your smart contracts, because of the nature of endorsement policy, those will be repeated multiple times. So imagine making a call to store something in the database, and as a result, you will save something multiple times. Also, one important thing that I want to mention is cryptography. IBM Hyperledger Fabric allow for a change of cryptography. So you can either rely on something called Fabric CA. This is native Hyperledger's tool for checking whether any participant is allowed to connect to the network, to execute operations, to call chain codes, and those certificates can be replaced with some external certificate providers. So when we are talking about nation scale CBDCs, usually there are regulations that could force you into national cryptographic solutions, and IBM Hyperledger Fabric allow for this swap. So there are also known drawbacks and nuances of IBM Hyperledger Fabric technology. You have to design your system in such a way that collisions and read-write conflicts are avoided. So when you call a chain code to execute some logic that will result in the transaction being created and submitted to the chain, there is some time buffer, time slag before this data would reach blockchain. And because of that, any other transactions initiated within this time frame and using same keys, same objects, same entities, they will be discarded. So let me provide you with an example. Just imagine something like Walmart or any other high transaction entity. So usually there are requirements from the government that each entity should be associated with only one identificator. And since everything is stored as key value pair in the world state of Hyperledger Fabric, then when you want to modify this key and let's say read it at the same time, then this will result in a conflict. Also, if you want to modify this key and then someone else wants to modify this key as well at the same time or within the time that is required to push a new block to the blockchain, then this transaction would also be aborted. So this whole situation is not good because just imagine you have something like Walmart. This entity has one wallet in your blockchain system, blockchain payment system, and this wallet is associated with some key in the world state of your blockchain. And then when you have multiple money transfers involving this account, you will have hundreds of key collisions, hundreds of conflicts. And this could result in only one transaction being successfully executed and committed, and all the rest would be rejected right away. And this could lead to hundreds of customers being angry, and this could also paralyze the entire flow of such huge entity as Walmart. So what could be a solution? You may want to allow for decentralized initiation of a payment transaction, and then you may want to introduce a centralized mechanism that would then iterate through all unprocessed transactions and execute them in a cycle. So imagine like your first phase, first stage. You just record something. Let's call it like an intent. Like you're recording an intent of someone to perform a payment. So this entity is being saved in the blockchain. No conflicts because you're working only with one unique key at a time. Just recording your intent to buy something or to sell something or just to transfer money. And then 1 or 2 seconds later, some centralized script triggers a chain code to execute all transactions that are pending. In this case, these transactions will first be fetched. Actually, not transactions, payment intent entities. They will be fetched and then processed in memory. And once everything is processed in memory, you now can push it to the blockchain. And in this case, you won't have conflicts. However, this approach makes it difficult to horizontally scale the system because it will always have a bottleneck in a form of centralized entity that triggers execution of pending payments. So in this case, I drew a hypothetical architecture of a CBDC system that is pretty close to real world pilots. So you can see that there are multiple participants. So you can see one bank. I called it JP Morgan Chase. Another bank, like let's call it Citibank, and also a centralized authority, federal bank. So every participant will store crypto materials for authentication, authorization in the system. A bunch of microservices to act as a gateway between the user calls and Hyperledger network chain codes. So I intentionally limited the number of deployed microservices for regular CBDC system members. And as you can see, centralized authority or a supervisor have these admin microservice which allow for some extra functionality. So deployment is pretty flexible. Also, supervisor might have something like cron jobs or scheduled tasks that would periodically trigger the logic available only to this supervising entity. So as I mentioned earlier, payment initiation can be decentralized. So you can see like a CBDC Pay API. This will result in pending payment entity creation, and a supervisor will be able to then call the chain code, a specific chain code to execute all pending payments. So usually when there is a new call to the system, it will be transferred to the corresponding CBDC system participant peer that would then execute chain code or smart contract logic This will result in so-called read-write set creation that will then be distributed across other peers to apply endorsement policy to verify whether all keys that were read from the world state or from the ledger and all the keys that were written to it match each other. And once endorsement policy is successfully applied, then there is another call to order in service to order transactions and push them to the block. Also, there is a membership service that could either rely on internal Hyperledger cryptography or rely on some external certificate authority, and basically that's it. So reflecting on my experience, I want to say that using blockchain for CBDC system creation is quite an interesting experience. However, there are certain drawbacks because usually when we speak about public blockchains, they just have to provide some degree of anonymity, transaction speed, transaction creation speed is not that important as long as money are transferred safely and anonymously. So if we speak about something like Bitcoin, I could be mistaken, but I believe certain transactions require multiple minutes just to be processed and committed to the chain. But if we speak about something that require supervision from the government, then public blockchain principles are not the answer here. But again, maybe it's a good practice to rely on blockchain only as a source of truth and still keep everything the old school way, like some backend, some database, traditional database, and then have blockchain for auditioning. So in this case, you store just some hashes in the blockchain, hashes of the data that is also stored in other data storages, and once in a time, certain institutions use it to audit the system to ensure that there is no corruption, nothing malicious was done, and so on. But again, what I want to say is that CBDCs perhaps might increase or may elevate the role of blockchain. So it's not longer about just startups or some DeFis. It's about regulated high trust systems. So basically, that's it. Thank you for your attention.
All right, Alex. Very sorry, but we do not have any time for the Q&A. We've got some couple questions in the chat, but I'll ask everyone in chat to address your questions directly to Alex. I'll create a separate topic in our Telegram group if you don't mind, of course, Alex. Are you okay with this?
Yeah, sure. I won't be able to answer all the questions due to NDA, but I think I will at least be able to share some anonymized experiences.
Okay, perfect. This works with us. And thank you, Alex, for the deep dive into the complexities of building the nation-scale blockchain infrastructures, and also sharing the fundamentals in the beginning. It was very useful for me personally. Thank you. You have a great one, and you will always welcome back on our stage at Blockchain Professionals.
Thank you. Thank you.
Thank you.
Have a wonderful day. Bye.
You too. You too. All right. Up next, we've got Dmitry Meshkov, CEO of Quex Technologies based in Cyprus. His session is dives us into Oracle technologies, security challenges, and design strategies, something that ensures reliable and trustworthy data in our lovely centralized ecosystems. Please join me in welcoming Dmitry. I think it's your first time at Blockchain Professionals here with us. You're very welcome.
Yeah, sure. Hi, everyone. Glad to be here. Do you hear me well? First question, because I feel my connection might not be perfect. If
We can
fine,
see you perfectly.
I'll start. Yeah. So yeah, glad to be here. Dmitry Meshkov. Let me, as I'm first time here, let me introduce myself a little bit. I'm originally a technical guy with a PhD degree in physics. Been involved in crypto space for 10 years from now, first as R&D department at Input Output, then as founder of Web3 project like Ergo platform, Circle Gain, wrote batch of papers in cryptography, distributed systems, economy, all around the blockchain space. And right now, I'm working on Quex technologies, C-based data and computation oracles. And today I'm going to tell you a little bit more about problems of data oracles and why it's so important, why do we have this problem at all. Yeah, because a simple question you can ask when developing your decentralized applications, what your smart contracts are capable to do and what they can do. Yeah, or they can read data from your PC or run a desktop applications or make network requests, or for example, turn on the light on the sunset. Yeah, it might be a smart contract, some kind of logics, but actually, it's not possible to do all of this logic directly from smart contracts, because smart contracts have to be deterministic. It's the main difference, I believe, between Web3 development and Web 2.1. You have to keep in mind that the results of your program should always be the same. This requirement is coming from decentralized applications because you have a distributed network, and all nodes should reach the same results, should find a consensus. What's actually happening here? What is the output? So if you have like output that is input plus 5, it's pretty simple. Yeah, input is 5, output will be 10. But if you need external data, for example, it may return different values for different nodes. They might have different permissions, different availability. They make their request in a little bit different timing. And if it's like prices, yeah, which is pretty popular in Web3 space, it will lead to different result, and they won't find a consensus. What was the exact response from Bloomberg API at this point of time? And the smart contract will fail. Yeah, the whole chain execution will fail. That's the Oracle problem. So smart contracts can only read data that is already on blockchain, and if you need any kind of external data, anything that is not in this particular blockchain you're building on, you have to bring this data on chain first, and only after that you can access to it from your smart contracts. So here is the place where special parties called oracles come into the game and doing their job for taking data from Web2 sources or from other chains and putting it on chain. There are different models how oracles works right now. I'll talk more about this during this session. At this stage, I'll take they might do it on a push model, for example, updating Bitcoin price every 10 minutes, yeah, or on every 1% price change, or pool based, yeah. So if anyone needs the Bitcoin price right now, they can pull it and use it exactly at the point when they need. Traditional model is push-based, so that's how Oracle started with pushing more and more data on chain. Actually, it's all started in a centralized manner, so we have some kind of trusted party that is pushing data on chain. But in this case, we actually lose all the benefits of distributed systems, of decentralized applications, because we have a trusted party. If we have trusted Oracle, we have a trusted party that can efficiently change the state and steal all the money. That's why we definitely need decentralized oracles and Web3 space that have to provide some kind of proofs of the data correctness. It might be, it might be proof that is consensus. We have a big network that come the decision that some data exists somewhere. It might be technical proofs. I'll tell more about this in this space. And yeah, I'll go in the numbers. I've already seen in the chat that's like 33% of attacks defined regarding Oracle. That's very big number. So 1 out of 3 attacks to DeFi protocols are coming through the price Oracle manipulations, data Oracle manipulations. This leads to hundreds of millions of US dollars losses every year. Besides of the fact that we already have quite a lot of oracles right now in the space, you likely know like Chainlink, Peace Network, API3, Redstone, and Quax definitely the new player here in the space. I'm building it. So before starting Quax, I thought actually that that oracle problem is solved already. The reality is that the problem becoming bigger and bigger every year, and I expect that it might be a huge problem with upcoming years when Web3 space will finally find adoption and will connect to Web2 space. Yeah, we see a lot of these movements like tokenizing real-world assets, so like in prediction markets, or traditional DeFi applications also. So we need data from different sources on chain, and the problem is not solved and becoming bigger and bigger. So as that Oracle's party, I mostly see a very simple request. We just need the current Bitcoin price. Yeah, so we have a protocol, DeFi protocol, and we need a Bitcoin price. But in this sentence, there are a lot of assumptions that are hidden, a little bit hidden. And when you're starting to talk with the client, you find out that they need a very accurate price, like this deviation 0.1%, with very low latency, few milliseconds, and they want it to be secure and decentralized and don't want to trust us or anyone else in this price feeds or other data feeds, because they can be hacked if data oracles they rely on will be hacked. and they will steal all the money anyway. Yeah, we see a lot of DeFi applications with billions of dollars value locked, and right now, as I remember, like 60 billion of US dollars rely on data oracles. So efficiently, if you hack all data oracles existing in the space, it will be possible to steal tens of billions of US dollars. Yeah, so the market is pretty huge in terms of stealing money. While it might be a very small, might looks like a very small piece, you have a huge application. The only problem here, you have untrusted price. Yeah, let's go further with the price example, and I'll explain why it's not that easy to deliver like Bitcoin's price. So the main, mistake made by a lot of developers sounds like, okay, we have a DEX, we have Uniswap on our chain or smaller DEX, and we can bring price, and Bitcoin is traded here, so we can bring price from the DEX. The problem here is that actually it's pretty easy to manipulate prices on decentralized exchanges, even on big ones like Uniswaps. That's where interesting example of flash loan attacks coming into space. They're still pretty popular. It was a nightmare 3-4 years ago, but still I see quite a lot of attacks that rely flash loans. So flash loan is actually again a Web3 unique type of loan that you're capable to loan a lot of money if you'll return it within the same transaction. Yeah, so it's very safe for lender. I have $1 billion. I can put it on flash loan protocol and tell anyone who will return me 10% more than took within the same transaction can take as much money as they want. And then what they do, yeah, they loan hundreds of millions of US dollars, push the price up, go to the protocol that rely on prices from this DEX. Right now, the price is 2 times bigger on this DEX, exactly at this point of time. Yeah, still $200 million, and then return 110 to the lender with a flash loan. The price goes down. Arbitrage will come into play pretty soon within the next transactions or the next block. But it doesn't matter because the hacker already got a lot of money with this attack. At the right side of the slide, I showed a few exploits related to flash loans attacks within the last year maybe. You can check by yourself if you'll go, for example, to DeFi Llama. There is a special hack page on their website, and type of attack is stated here, so you can check attacks that are related to data oracles. Within the last month, there were, I believe, 2 big attacks with tens of millions stolen. But sometimes they are very big, so you can see attacks that the hacker steals hundreds of millions, and that's definitely a death for the protocol. A lot of people losing their money, just because we don't care too much regarding the price. It looks like a very simple task, just the price, but we have to be very accurate here because it's possible to steal a lot of money. The attack profit is very high, and it opens the way to create very complicated, sometimes very interesting attacks that also that are costly, but the attack profit is high. So yeah, okay, let's go and let's grab the price from the DEX. It's the snapshot, I think 1 month ago to 2 months ago, maybe. But the situation is still the same. If you go to different exchanges, to different pairs, we'll see different prices. And if you have a decentralized Oracle network, and one node takes from one exchange, another one takes from another one, from different pair, they still need some time to find a consensus. They might calculate an average of all their volumes, remove some values that different significantly from the average price. So there are techniques how to find a good average price, but it takes time. Yeah, it takes time. We need a consensus among all of these nodes, and here we'll lose the point of bringing data very fast on chain. Yeah, sometimes we need it very fast, and it's crucial to have a very accurate price. So yeah, prices vary over time, vary over exchanges, vary over trading pairs, and even like on tier 1 exchanges on pretty low volatility markets, prices might range with few percent. People solve this, trying to solve this issue by describing exactly the algorithm, how they calculate the price. Yeah, that's what we see in Hyperliquid, for example. So you take Binance, OKX, other exchanges, they all have weights, and in some conditions we take Hyperliquid prices if there is a spot market. And so there's exact set of rules for all the nodes what we consider as a price. Because to find the truth actually is not that easy. We'll see it a little bit later in different examples, not just for prices. But yeah, for when we define the price like that, at least we have the rule how to calculate it. We can find a consensus how we calculate it. We still have problems with the timing, yeah, because we may make requests on different times, but at least we are doing the same calculations, the same aggregation on our side. So that was the price example, and it's called like multi-party computations, MPC design. So we have a lot of nodes that are making requests the same data sources, or maybe the different data sources, it might depend. They calculate their own result. They run consensus among themselves to find a final number, yeah, and push this final number on chain. This approach is very good for like traditional Oracle's push-based, when you have pure stable like price feeds. So you have we know that in a lot of cases DeFi applications use Bitcoin price, so we can push Bitcoin price, and all the DeFi applications that rely on it can take it from like known smart contracts that contains this price. And actually, it's a pretty good approach. However, it's pretty slow as we need a consensus among different nodes. It's not that easy to add new data feeds because through all the network we have to agree that right now we're also calculating a new price feed and starting to push it to this contract. Yeah, that's a new that's some kind of update. We have to update all our nodes. They have to know where to go to get the numbers. And I'm talking just for numbers right now. It's pretty simple number with like price. And the last topic I would like to emphasize here is very important from my point of view, is a kind of security guarantees you're getting from the concrete approach. And in a lot of cases, for data oracles, especially in MPC design, your security guarantees are like economic. So Chainlink have its own token. We have to stake this token to become validators and start to participate in the validator networks, run the consensus, get rewards from this price. But the issue here is it's possible to buy a lot of tokens, perform 51% attacks, or like bribe other validators, telling them, "Oh, I'll pay you big amount if you'll push in correct price." And it's not just theory. We'll see it a little bit later. The problem here is that none of oracles are capable to provide this kind of guarantees. So every project, every oracle that relies on security guarantees like that secures much more than the token market cap. Even if you're talking to Chainlink, like the biggest oracle right now, the token market cap is for about 10 billion, but they secure 40 billion. So there is a 4x potential profit if they will behave like dishonest, if they will behave economically rational, actually, if they push the data they need and just steal money from the protocols they're securing. It's pretty dangerous situation, I believe. In decentralized applications, we don't want to trust to anyone. We don't want to rely that parties will behave honestly, will behave as good actors. Yeah, that's why we have technological guarantees, cryptography, and all of this stuff. Yeah, I just told about all of this. Yeah, for Chainlink is 44 billion in maybe a month ago, but it's still possible to steal a lot of money. Yeah. That's metric calls total value secure. It's pretty public. You can check from different oracles how much they secure, and you can check actually how they secure these tokens and how much money do you need to break this kind of security. For Chainlink, you need a lot of money, but the reward is also pretty big, very big actually. So keep that in mind, especially if you're building applications that potentially will secure a lot of money. So I told regarding MPC design that it's good for secure, stable price feeds. But what if we are looking for like unstructured data for about, for example, prediction markets, make bets for different events, event results, or election results, or some events happening in blockchain space or outside of it. Here, optimistic oracles usually come into play. The most known example is Zoomer Oracle, serving as an oracle for polymarks, and it works like that. So we have an event, and we want to resolve this event. In most cases, it's yes or no, but there might be more options. So, just will Trump will be a president of United States on July 1st? And we can make bets, and someone have to resolve this event. Yeah, optimistic design means that there is optimism that we believe that everything will go quite good, but we have a protection against misbehavior here. So a sort of sends the data points on July 1st. He says, yes, Trump is still president, and challenge period started. Any other participants of the network can start a dispute telling that now that sort of sent incorrect data point. They have like 2 hours in most cases. So within 2 hours, they can start a dispute. If dispute is starting, the voting for correct result is starting. It's pretty slow and manual process taking a few days, like 1 day maybe. So people are starting to what exactly happens at what events. And there are rewards to correct voters. There is punishment for incorrect voters. It's again rely on economic security guarantees. So you vote with your tokens, UMA tokens or Oracle tokens. Dispute process is very slow. Hopefully, they're slow only when dispute started. When dispute not started, it might be more or less fast, but again, it's not real time. It's a few hours because we still need this time to start disputes if anyone send incorrect data. And for unstructured data, it's pretty good design. The problem is surprisingly, sometimes it's not that easy even for us as a human to realize what is the truth. Yeah. So for blockchain, as I told, smart contracts have no idea who won yesterday's football match. For me, it might be pretty easy. I go to sports website, or maybe I watched this match live on the stadium, and I know the team, the exact team, won yesterday. But there might be cases when it's not that easy. The match might be cancelled and so on. So there was a pretty interesting issue on Polymarket a year ago regarding Ethereum ETFs approved. So the question of prediction market looked like Ethereum ETF approved by May 31, but it wasn't stated what exactly approved means. Yeah, and there are different forms and regulation that have to be approved before going live, and 19B form was approved, but the second one, F1, wasn't. It's not that easy for regular people even to understand. Was it approved or wasn't? Was Ethereum ETF approved or not? So it was approved, but it wasn't possible to trade it on public exchange, so that you can launch. And there was pretty big conversation in social networks and community Polymarket whether how we can resolve this kind of issues, because we missed likely at the early beginning. Yeah, we missed to define exactly what approved word means. That's I'm telling this to you just to realize that sometimes it's not that easy to understand the truth, to answer a very simple question. Yeah, very simple question with yes or no response. Both can be easier, but in this case, it happened that it's not that easy to realize was it approved or it wasn't. The second example from the same Polymarket I'd like to show to you is more interesting, more fresh from this year, and there was a bet like Ukraine agrees to Trump mineral deal before April. In reality, the deal wasn't signed, but market resolved as yes on March 25. For sure, community initiated the dispute that is incorrect response, but it was finally resolved to yes on the same day because few whales voted that this market yes. Yeah, and it's like 7 million losses for ones who bet to no result, and 7 million win for ones who bet for yes result. The problem here is the voting power. If you go to the right bottom side, you'll see the distribution of voting tokens among top holders. You'll see that just 2 accounts hold 51% of that. We have this issue actually even on public blockchains like Ethereum, Solana. Yeah, we have this concentration of voting power, of hash power, if you're talking about proof of works blockchains. If we rely additionally on oracles, we have the same issue. Yeah, we have two levels of this issue. There might be like 51% attack on low level, on the blockchain level, that might steal a lot of money from different projects. And again, also additionally to that, we have this potential problem in oracles setup. The one example I'd like to show to you is the private oracles. Pretty fresh space, just because technically people were not capable to do it just like 3-4 years ago. The problem with the prices or with bets, it's not an issue to push data on chain. But if we're talking about sensitive information, user belonged information, we cannot push it on chain for just as is. Yeah, it's just illegal. The simple example here is, for example, you want to show that you are a accredited investor and you have 100K on your bank account. You might want to show this to prove that you are eligible to do this, to participate in this DeFi protocol. But if you provide the whole response from your bank, it will contain your passport number, name, surname, distribution of your assets, your money among different assets, the exact amount of money you have. The only thing you need is to prove that you have access to this 100K account. Yeah, but you don't want to reveal your name, surname, and so on. So this, like private oracles, we also belong to them. Usually injects in TLS and encryption piece of communication pretty standard, and can like certify every single HTTP request, proving that right now this data source return this response. It's not necessary. We have to extract only necessary information from the response and push it on chain. Yeah, that's good for private data that is suitable for user-centric data, specific data. You have to trust to data sources. Keep it in mind anyway, because if we are bringing prices from exchanges, usually bringing it from a single one is not a very good option. If we are bringing sports events results from sports API, we have to trust the sports API. If we are bringing data from a bank, we have to trust this bank. It's not a complete truth. Yeah, we don't prove here that a user owns 100K. We prove that right now bank responds him that he owns 100K. So it's again very very small difference in definitions, but it might significantly change the vision how we hold this. And finally, I have to mention here that in most cases for these private oracles, we have very non-trivial security guarantees. They might rely on trusted execution environment, trusted hardware. That's what we are doing, for example. But in this case, we have to trust to manufacturer of this hardware. We have to trust them anyway, actually, like to Intel as a manufacturer. In my case, it's more crucial because we rely a lot on the verifiable like confidential computing features. We rely on confidential computing proofs. It might be a ZKTLs approach that rely on zero knowledge proofs, but again, ZK is pretty fresh, non-standard cryptography that's widely adopted, but it's not as secure as the standard cryptography we use every day. So again, keep it in mind in lots of cases that it's okay to trust to hardware manufacturers, right? Like Intel, few of them. In some cases, you might not want to do it. So yeah, finally, I'll tell a little bit more about Oracle work. One more approach we have is like first-party oracles, where data providers itself install special software on their site and correctly sign the data that we can verify it right now. So if all the internet would be like that, in most, I believe we wouldn't have Oracle problem. But unfortunately, responses from most APIs, most websites are not signed, and you can ensure for yourself. I can ensure that it's response from Bloomberg, but I cannot prove it to third party. I can convince the third party that Bloomberg returned me this response. That's again a big difference actually, because we already have an internet. We have a lot of cryptography under the hood of our browser and every connection we use. But yeah, I cannot convince anyone that I got this response from my colleague who told me something via Zoom. Yeah. Few more things that typically oracles do. It's again goes back to one of the first slides from my side. So smart contracts have to be deterministic. Network requests are not deterministic. That's why oracles solve this issue. If you need a pure randomness in your smart contracts, you cannot get it like out of the box in smart contracts. That's why you have to rely on verifiable random functions. Most of oracles provide this functionality also. So just randomness, but verifiable. Oh, it looks like, yeah, I hope you hear me and see. It looks like electricity turned off in my city. Okay, I'll continue like that. Interoperability problem is also pretty new, because we have a lot of chains, blockchains, and I told that like smart contract can extract data from the exact blockchain it is running. So if you're building on Ethereum, you cannot get data from Solana or from Bitcoin or from Cardano. Yeah. So this kind of cross-chain messaging for bridges to bridge assets among different chains to build multi-chain apps is important to create a world where final users won't care the blockchain under the hood and will just use the app. And there are more interesting cases like automation. It's related to a little bit different problem. It's related to the problem to initiate a smart contract. You need a user. You need a user who actually start a transaction. So smart contracts can't start by some conditions. That's why oracles might also initiate execution of other smart contracts. It might be just timing every hour, start something, or condition based, like if the price changed 1%, start execution of the console of football match ended. We push the result and execute the resolution of betting apps. So the conclusion I'd like to tell today, I wanted to show to you that the Oracle problem is pretty unique for Web3 space. If you're a Web2 developer, you don't know what is Oracle, but it still remains unsolved, and it's growing in the scope in the space. There are different trade-offs for different Oracle models. You have to choose very carefully how to grab what kind of Oracle to choose, and how to use it actually. Also, Oracles provide everything a part of basic smart contract functionalities. So if you need anything that is not supported by smart contracts, take a look to Oracles. Likely they do it. It might be randomness, cross-chain messages, verifiable AI inference, whatever you want. And yeah, Oracle defined the trust and execution boundaries of Web3 applications. So thank you for your time. It was a pleasure to be here. I'm ready to answer questions if you have some time. I think I took exactly 30 minutes as I should. So
Do not have much time, but I think we can take one question if you could answer to it very quickly. I think it's very interesting. Here it is on your screen.
Okay, I see. So will the next 1 million DeFi hack come from Oracle manipulation of Trump's smart contract flows? I don't know exactly what will happen in the future. I think we have a very, very good chance that it will come from Oracle manipulation. Smart contract flows in most cases are pretty good if people know how to work with smart contracts, how to make security audits. So I see not that much hacks right now from badly designed smart contracts. In most cases, the hacks coming from side channel attacks, not the main logic of smart contracts, but from oracles or logic that economic attacks like that. So yeah, I believe we have a very big chance that it will come from Oracle manipulation. Definitely there are hacks like stealing private keys, hacks from centralized exchanges. Still the biggest in the space. Likely you all heard about 2 billion hack from Bybit this year, the biggest hack in the history. But yeah, just keep in mind it's important to remember that oracles are also vulnerable, and it's additional level of security, but additional risk to your funds if you're using blockchain or to your protocol if you're developing there.
All right, Dmitry. Thank you. Thank you so much for your insightful look to how blockchain connects the outside world through secure data oracles. It was a pleasure having you on stage, and you're very welcome for our next sessions.
Yeah, thank you very much. It was a pleasure to be here. Have a nice day, everyone.
Thank you. Already, next up we have Dmitry Lahunouski with his highly anticipated talk, Why You Still Can't Buy Coffee with Crypto. If you ever wondered why crypto isn't yet part of your daily transactions, this is a session you don't want to miss. And let's give a warm welcome to Dmitry. Hey, Dima.
Hi, Farouk. Yeah, hi, everyone. So yeah, I picked a quite interesting topic because I was digging into it quite a lot. Yeah, let me just quickly share some small presentation. So we can start. Basically, I think people, especially people who follow crypto space maybe since 2017, so even earlier, they remember these promises about, hey, soon we're gonna be able to pay with crypto everywhere. You can buy a coffee with it, but it looks like it's still not a reality. So I tried to summarize all my knowledge about why it still hasn't happened. But before that, I want just to do a small step back and ask and answer the question, actually, why is that actually important? And I think the simplest way to explain this is just to demonstrate how currently, for example, the payment with a Visa works. Yeah, you see it's quite a complicated system with a lot of intermediaries. Most of them basically also custodial intermediaries, so they taking risks, they taking fee for these risks, and quite annoying, especially for merchant, when you need to pay huge fees for that and wait when your bills settled on your personal account within like 1-2 days, or even more when you're trying to sell goods during the weekends. Yeah. On the other hand, we have like, I just draw this very simple diagram because it like the purpose of this diagram is just to highlight the simplicity of the blockchain payment. Yeah. On the very basic level, just you authenticate transaction with your private keys, then you send this transaction to the blockchain. You have a real-time processing and settlement, so merchant can almost immediately receive the funds from the user and be sure that these funds belongs to him and he can already also spend it. Yeah. So but despite of this simplicity, like it looks on the first at the first look, we still struggle to integrate this system into our everyday life. Yeah. So I wanted to summarize kind of the requirements that usually merchants or even like user wants to have to be able to pay with crypto. Most of these requirements comes from our just daily user experience, how we used to pay, what we do expect from the payment providers. Yeah, so I put here maybe the most for the most important things. The one is obviously throughput and peak handling. Yeah, so we as a users, we expect that we can pay in seconds in whatever day we want. Yeah. For the merchant is also important is a finality, at least a couple of days, but still you want to have the guarantee that the transaction that are confirmed by POS, for example, is going to be settled and you hold this money. Yeah, so you can give the goods or whatever you're selling back to the buyer immediately. Yeah, and the third one is cost stability. Because initially when Bitcoin appears and we didn't have a lot of crypto, one of the drawbacks of the payments with Bitcoin was the price instability. The fluctuation is very high, and the fluctuation of the price can happen within seconds. So it's not acceptable for merchant. If you want to sell something, you would like to expect some, I would say, predictable revenue. It's important for your business planning. So you cannot rely on something that's really volatile relatively to other services or goods. Yeah, so the cost stability was very important. And another, like the fourth, is basically that was probably achieved by the crypto immediately, I mean, at least from the Bitcoin side, is the reliability and resilience. It's you expecting to have a 99.999% of reliability, so you don't want to accept the payments as a merchant through the systems that do not work often, or that risks to kind of lose your money. Yeah. So let's kind of compare the performance reality check. Let's do a performance reality check. Yeah. So what we currently have, I just put three the most popular cryptocurrencies. Obviously, they have a lot of extensions, features that are not represented here. But anyway, it gives the comparison of what we can expect currently when we use for example, Visa as a payment network, or we use a Bitcoin, Ethereum, or Solana. Yeah. So you see that regarding the through output, we are not even close to the possibilities of Visa. This through output is basically not something that Visa handles every day, but at some, for example, during some events, users can transact a lot. So our system needs to be able to handle this smoothly. And we obviously existing layer one blockchains do not handle even close amount of this transaction per second. Yeah, finality also is quite important. Here is finality meaning kind of a soft confirmation when the merchant and user receives a feedback that the payment is processed, and the kind of the possibility of the payment is not going to be processed is like below meaningless values, such like 0.000%. Yeah. So for Visa, you just, for example, use your card or smartphone, and you immediately getting back a feedback. In a Bitcoin, you usually have to wait like around an hour, just because you cannot even rely on one block confirmation. You need to wait for a couple of block confirmation based on how the hash rate Bitcoin works. And on Ethereum and on Solana, the finality is faster, but it's still not comparable to Visa. And the last thing I think also that we can compare here and highlight is the cost of transaction. Yeah, for Visa, I put here as a static value, not a percentage, because my topic was about buying the coffee. It's basically how much dollars usually merchant gives back to all intermediaries when you just buy one coffee. It's quite high relatively. For example, the coffee price like $3, but yeah, it's still bearable for them. Yeah. And what is important that usually the percentage is fixed. You have an agreement with acquire bank, and it means that you can also predict this cost and put it into your business planning. While if we talk about Bitcoin or Ethereum, the costs are very unpredictable and based on a lot of factors. One of the main factors is a network congestion. So when network is very busy, there are a lot of transactions that are pending. The cost of the transaction might be significantly high, like 10 times, 50 times more. In a Solana, these are usually not the case. But anyway, during, for example, NFT minting, it still might be the case when even on Solana, your transaction not cost a lot, but still pending in the kind of local pool. So it's not processing, and the finality increases significantly, or you can even have a cancellations of your transaction. So you will need to resubmit it once and once again. So it's still kind of it's not cost related, but the user experience related to this cost fix is, I would say, not ideally designed for now. So what are the technical roadblocks? Basically, what do we need to do? What do we need to achieve to make crypto usable for daily payments? And this is just a pure technical roadblock. So we are not touching any social or legislation or economical parts of this question. So from technical perspective, we just want to have a reliable networks that do not halt. It means that, for example, we currently have a very reliable but very slow networks like a Bitcoin or Ethereum. We can have a less reliable network which is faster, like a Solana, or we can even have a very fast also network which just have a one point of failure, like L2 networks on top of Ethereum that usually operates just with one sequencer. So it means like if sequencers either pause or censor your transaction, you can enforce it at some point via L1 layer, but it's still kind of it still might block you to properly use this network. Another big challenge, technical challenge for crypto space is a fragmentation. Yeah, we already have a lot of chains, and creating kind of a wrapped solutions to just roll out your own chain makes it even worse. So as a merchant, for example, I don't want to care about receiving payments from like 15 chains. Yeah, what I would like is just to accept, for example, USDC on my wallet, which is hosted, for example, on Ethereum, yeah, or on Solana. But I would love to accept payments from everyone. So if somebody hosts his funds on other chain, I would like to be able to get these tokens on my chain. Yeah. So the fragmentation is a huge user experience problem. It also introduces additional technical problems such as trust minimized bridges that are not trustless and usually got hacked. So you can lose your money during transaction or even lose all your funds. It also introduces additional latency, additional intermediaries. So we're kind of making the whole system is much more complicated, and our system becomes looking like the Visa, but with less guarantees and worse user experience. Yeah, but still, this is an ongoing process. So we're the crypto developers trying to improve it. Everyone trying to. Every day there is any startup appears that trying to solve this. But yeah, this is currently a roadblock. Fee volatility is also a big headache, as I already told, for merchants. So basically relying on currently, if fee is meaningless, until a fee is meaningless, like below, I don't know, $0.0001 per any transaction, it might affect the merchant operations. So the solution here is either to lower fees for a very low amount or make them predictable or even better constant. Yeah. Another on top of that, when we even if we have all of these previous roadblocks solved, we still struggling to have one of the most important is the scalability. The system's still not able to handle 65,000 transactions per second. And the problem is that scaling blockchains, if you want to keep the decentralization and security on a high level, it means the chain should have a lot of nodes that operates. It introduces a latency problem. So we need to synchronize thousands of servers that are distributed among the whole world. And another issue is, even if we solve this problem, there are also a storage bloat problem when if even we calculate that the transaction, for example, takes, I don't know, 32 bytes, it's still, if we multiply it to 65 transactions, 65,000 transactions per second, it means that during the year, the storage will increase significantly. Even now, Ethereum, for example, as far as I remember, the full node for Ethereum will need to store like around 2 terabytes, but we only have 7 transactions per second. Yeah, just imagine how many terabytes needed for node to store all the data. This all leads us to this consensus triangle problem, where we should kind of balance speed, security, and decentralization in order to achieve the best user experience, while trying as much as possible to provide the service to be decentralized and security, to keep system simple, as I already described in the previous slide, when you just send a transaction and the merchant receive the funds in real time. This is a technical roadblocks. Yeah, most of them are solvable. Most of them are either partially solved or will be solved soon. And we will talk about it a bit later. But there are also legal and economic roadblocks that also complicates the innovation. It also complicates the crypto integration with existing payment infrastructure. Yeah, and even if we solve all technical roadblocks, they might be not interoperable with existing laws. They're not interoperable with existing infrastructure. So it's another huge challenge for crypto and the whole ecosystem to overcome these, to work with regulators, to kind of educate the regulators about the nuances of the decentralized system. I just picked a few important parts here. For example, the privacy versus compliance. I think the audience might know that currently we have privacy crypto like Monero or Zcash, or we can even do a private transaction on Ethereum using zero knowledge pools like Tornado Cash, ZK pools, or Railgun. But it's the problem with the DK solution is that it completely removes traceability. It also increases the transaction cost and slows down them significantly. So, but regulators usually demand a full traceability. They want to see to whom you pay and for whom you receive the funds. Even introducing the KYC and AML policy for on-ramp and off-ramp functionality, like when you change your crypto for fiat, do not solve this problem completely, because AML policy, for example, requires you at some point to disclose the source of funds. If you receive these funds from either ZK pool or just an anonymous wallet, it's hard to prove what the source of funds, especially cryptographically. Yeah, if you receive the funds on the public blockchain, you can obviously at least show the traceability. But if you receive funds in such a cryptocurrencies like Monero or using ZK pools, you even cannot prove to the regulators from whom you received these payments. This makes the compliance very complicated, and this blocks basically even just the normal businesses to even start accepting crypto in a non-custodial way, because they're just afraid that they won't be able to use these funds later. We also have a regulatory flux that rules changing very often. They are still unclear. So there is no country in the world where you can kind of rely on some crypto regulation rules and be sure that they're not going to be changed within 2 years or 3 years. It's a development, it's ongoing development. So, and obviously regulators doing the mistakes They constantly involving with the crypto community. This uncertainty adds additional risk not only on the crypto players, but on the merchant side, also on the developers. So, and operating in a huge volume business in such a high risk environment, just meaningless for now. So that's why I think it's one of the main points why current even like banks, for example, do not settle their internal transaction between each other in stable coins. Yeah. Stablecoin jurisdiction, just a part of this regulatory flux. We see the improvements here. There are a lot of steps forward for regulate stablecoins, but still, even in some countries, there is no differentiation, for example, between decentralized stablecoins like DAI or algorithmic stablecoins, or like centralized fiat-backed stablecoins like USDC. So until there is a clear rules how you can utilize them, how related, a kind of it's not possible for merchants to use these tokens as a primary payment. Volatility risk is another kind of really illegal issue, because if you accept tokens that are highly volatile, usually they are considered as not as a currency, but and it means that you need to pay a capital gain tax on it. Yeah, and just imagine you're a merchant who accepts payments in Ethereum. Yeah, and then at the very end of at the year, you have to check all your transactions, calculate for every transaction how much Ethereum cost at this moment in, for example, local currency. Then you have to sell and pay additionally capital gain, which is quite high in a lot of at least European countries. I basically live in the UK. It's 20% here. It's quite high, so nobody wants to pay this, and nobody pay these high additional taxes. So user will try to back to the accepting either stable coins or just using fiat rails, payment rails. So and another kind of a barriers that we have is a social. Yeah. But most of them are coming from the technical or from legal or economical barriers. Yeah. So one of the things is the trust. Despite the blockchains are kind of trustless, where you don't need to trust your counterparty for accepting transaction, on the psychological level, people still operate with trust. So even if you, for example, have a very fancy idea about how to process payments using a blockchain, you will need to to develop and to educate merchants so they can gain a trust in your system, and only after that they will accept this as a payment solution. And media perception is also one of the social barriers, because crypto, since it's an open system, there are a lot of good and bad happening at the same time in the crypto, but people usually focus on some bad things, like, for example, hackers stole some money, or one more centralized exchange closed, but all of this is associated with crypto as a whole technology. So most of the developers, not developers, I would say, even most of the crypto enthusiasts, they face this kind of media perception that you are part of some shady world that just exists for money laundering and nothing else, and for scamming people. We also have a user experience problem from the social perspective, because holding the seed phrase from your personal account might be good for the self-custody, but it also introduces additional user experience problem, such as a recovery. Imagine you hold 100 Bitcoins. It's an enormous amount of money right now. And then you suddenly, I don't know, just die or you just forget your private key, so you just lost it. So in using a banking system, you can easily recover those funds. Not easily probably, but still there is a way to do it. The user experience about recoverability is, I would say, currently in the middle of development. There are a lot of startups who is dealing with it, but it's still not well developed and established. Yeah. So, and the last thing is a chicken and egg problem. I think for merchants and for users, there is a chicken and egg problem that merchant doesn't want to accept crypto payments until he knows that he can accept that everyone can pay with it. Yeah, and the same for users. If you cannot pay with crypto everywhere, that's a problem because you're not going to use it, even if it's better than just using Visa. So there is a solutions currently that helps us. It's a roll-up scaling and high-performance validator solution on the Solana fire dancer. So I think we will break a lot of technical roadblocks within next 1-2 years. And we also will break some social roadblocks like smart account recovery. There is a bills that introduces and regulates stablecoin. Stablecoins become like a programmable default money rails. So anyway, until despite a lot of roadblocks, the future looks bright for the crypto. I just post like a very short vision about how, at least from my perspective, it looks like that in the nearest years, I think the transaction and throughput problem will be solved completely. So I'm expecting that virtual payment services start using stable coins as a settlement layer by default. So we see the movement, for example, from Revolut, from Stripe, who acquires recently 2 startups. So it looks like a lot of the I would say fintech companies, classical fintech companies, are looking into USDC settlements, stablecoin settlements. PayPal uses his own stablecoin for that. So I think it will become as a default settlement layer because it reduces a lot of headaches that currently payment system has. Hopefully, I put it here 2027, and I don't know where, but there is a lot of development regarding ZK attestation that replaces KYC and AML. So you don't need to disclose the whole information about yourself, but a very tiny zero knowledge proof that you, for example, allowed to do this transaction. So it might significantly increase user experience and safety of the crypto payments while still preserve privacy. That is a quite important topic in crypto. So yeah, looking forward for the ecosystem. It was a talk about the problems, existing problems in crypto payments. Thank you for your attention. Hopefully it was useful for you.
It definitely was, Dima. Thank you. We've got some questions for you to answer. Want to take a look at them?
Yeah. Yes, I think it could definitely match and even overcome these uptime. It's not something that that is not doable. Even for now, there are kind of local tests about even EVM handling 100,000 transactions. There was a lot of developments, improvements in the how we store the data, the transaction data in the blockchain, because by default in the Bitcoin you store everything in the Merkle tree. Yeah. So, but there are improvements about Merkle trees, like Versal Merkle trees and others improvements, specific database for Merkle trees. So the through output and the execution speed improves significantly. So yes, I think it's very doable. How does Solana claim to 1000 TPS hold up under real-world conditions during network congestion and spam attacks? Solana infrastructure is very, I would say, innovative and interesting approach how to deal with the blockchains. They have a quite different approach how they manage user accounts. They have this parallelization. It means your in a EVM, all the transactions are atomic. If you, for example, send your tokens to a smart contract, and then the smart contract do something with your tokens, and then send it back, I don't know, to POP. Yeah, this whole transaction is atomic. It means if something fails in the middle, the whole transaction fails, and it's absolutely synchronous. Yeah, in the Solana, the approach is different. If you deal with, for example, some stablecoin, it has a separate accounting system, and Solana can perform the changes of the accounts in isolated way, yeah, like asynchronously as a separate, I would say, like a thread, yeah, like a separate process. So it allows Solana have a unique features, how, for example, to process transactions in parallel, which is not interconnected. And it also allows Solana to have local markets for these transactions. So even in the network congestion, for example, you have a big pool of transaction waiting for swaps, but there are other transactions waiting just for transfer money. So since they're isolated, the processing and verification of the day of the transaction for transactions for simple transactions will be faster. So they'll get processed faster and cheaper. While the swaps will have their local market and prioritization according to the fee. So I would recommend definitely to dig into Solana approach, how they achieve such a huge throughput, still having, like, as far as I know, currently more than 200 validators in Solana. I mean, big validators. So yeah, it's pretty impressive job.
We've got the last one here.
Do you have any comparison of electricity used to modern state emission to make a single transaction in Visa and blockchain? Are they significant? So it's a quite holy war topic about the electricity that's used for anything. We can start like philosophical question even about the cost of electricity and how much electricity as a society we're using. For example, we do not use even less than 0.01% from solar energy that we can build and use here. Yeah, but answering your question directly, blockchains are different. There is a proof of work blockchains, proof of stake. For proof of work, obviously the electricity it's very electricity expensive, but it kind of compete with other electricity usage. So if we, for example, imagine some country, there is a Bitcoiner miners and there is a factory that produces some tools. Yeah, if the production of the tools is more profitable than mining and processing transactions, then people will produce the tools. If the transaction is more profitable, then people will switch to the transaction. And the cost of the electricity changes within your daily usage. We have a spikes in the electricity usage, or we have a night when nobody uses except probably factories. So you can even, for example, use your electricity in different time differently. Regarding the, for example, so I think it's a very good example for Ethereum, since Ethereum have like around 9,000 nodes right now. So it's still quite intensive for electricity usage comparing to banking system, I think. But you still also need to understand that the banking system, especially digital bankings, are also electricity expensive because they also need to operate a lot of services to for example, handle the QC and ML, or for example, validating your accounts and all this stuff. But I think it's I actually don't. I have never developed such a deeply banking payment system. I just developed some payments system in the blockchain. But my imagination that the banking is more effective because obviously they are centralized. Yeah. So something that's centralized will be always more effective in consumption of resources. The question should be is what are we getting back from that? Yeah, what are we getting back from having systems centralized or decentralized? And I think for payments, having decentralized system is much more important than having more efficient centralized. But this is another philosophical talk about it. Yeah, I think that's it. Thank you for your question, guys.
All right.
Enjoy.
Yes, guys, thank you for your participation at Dmitry's session. That was truly an eye-opening dive into challenges holding us from crypto payments. Well, thank you. Some truly crucial insights for anyone working in this space and I mean living in this world facing crypto. And yeah, it was a pleasure having you here, Dmitry. Thank you so much for your time.
Thank you. Thank you.
Okay, see you next time, Dmitry. And next up, we're shifting gears to something equally groundbreaking. Please welcome Dima Burov with his session, AI-driven container DevOps on DeinFra. Well, it explores how AI and blockchain are revolutionizing DevOps by automating container, and Dima, correct me if I'm wrong, automating container deployments securely and transparently on decentralized infrastructure in just 60 seconds.
Yes, hello. I'm Dima. I'm CPO of DeinFra, and today I will talk about some mix of AI agent and cloud blockchain technologies. And in the next half hour, I will show you how DeinFra's AI agent turns a plain Docker Compose into a fully running blockchain secured environment in 1 minute. You don't need to Helm, Terraform, and something like that. Think like Vercel level user experience, but focused for AI workload, DeFi, and so on. And it is cryptographically locked into your wallet. And let's go. We have an agent that help you to manage and deploy your project. You can ask, please help me to deploy my project. And the agent will ask you some questions. And for example, for your Docker Compose, or it helped you create some new configuration. And here's the plan. Median cloud rollouts in 1 month, even trivial microservice writes in roller coaster CI jobs, infrastructure as a code plans, approvals, and so on. Infra costs grow up each year, and my personal is around 100 YAML files, sprinkled around 3 clouds, because we have a multi-cloud in the future. And enterprise dive in CI/CD, glue code, GPU spends a rocket, and blockchain pilot takes years instead of days or weeks. And we need to radical simplification of this stuff. And here's our answers. 5 steps, each automated. No manual secrets, no IP whitelists. AI agent parse and optimize your public key, hash the compose, store in the manifest on chain, and spin up nodes. It's encrypt your container. Every is encrypted by your private key, and you can manage it with your wallet. And then we create smart contract ticket. The manifest is hashed in our leaderless BFT chain. The transaction is immutable. And network schedules containers for runners, and the job, it takes around 1 minute for average case, and no helm, no kube context, and so on. And we don't ask you to learn a new DSL. This literally Nathan Docker Compose snippet, one of the most popular tool for AI agent, exact what we took from the documentation. Agent infers GPU class, allocate RAM, creates and volumes, and bakes and rollback plan. So what are we? AI first DevOps fabric that lets you ship containers to a global EVM compatible compute network with private key security. Think like a Vercel level developer experience meets ledger grade auditability. That single sentence is why enterprise and startup is piloting with us. Even DeinFra admins can work with your containers. Let's unpack the security claims. You sign the manifest. Agent use your wallet, and the hash lands on chain. Project encrypted with your EVM key. Runner policy. Not can pull only after smart contract verification, sign and stake. This best effort security and zero trust from laptop and GPU, no plain text, and so on. We extend the principle of identity and access management. Wallet equal identity, no static passwords, no lost SSH keys in Slack, and so on. Fine graded scope via smart contracts. Need to return the metrics, sign a role token. And the architecture is under the hood. We made it a leaderless BFT chain with AI control plane. As a result, order of magnitude faster provisioning. LLM agent model agnostic. For example, you can connect Olama, OpenAI, O3, GPT-4.1, Anthropic, and so on. And synchronous BFT consensus for censorship resistant, leaderless, and it has instant finality. Container optimized runners. It's work around a lot of regions, and why leaderless? Fewer bottlenecks than Raft, Kubernetes masters, and why BFT? Because we can spend several manifests for several nodes and so on. And some results from our early adopters. Our beta teams report 70% fewer work on machine for tickets, no manual configuration, and it reduce the number of bugs, and you don't need to maintain manually, and the agent help you to build and release for production. No missing environment variables, open ports, bed limits, and so on. And of course, in our on-call hours, cut in half, less YAML files, and decentralized supply, squeeze unit cost, while AI packing slashed cold start latencies. Total cost ownership drops more than 30 seconds. Money talks. and cold start latency decrease 5 times, for example, and typical Kubernetes cluster. And the pricing model is very simple, pay as you go, no hidden fees, and so on. And I have some small video how it's usually work. You can ask the agent, hi, please help me deploy my project. And then the agent asks you for name of your project or some other parameters. And after that, it will deploy your container for production. And the path for your pilot, you can sign up and connect your wallet. You can choose Web 2 providers, Google Cloud, or GitHub or something like that. Or you can connect to your MetaMask. For Web 2 providers, we will create account abstraction for you. If you will have your, for example, MetaMask, you will use your private key from MetaMask. You can pass compose, or you can ask the agent for create the new one. It can check, for example, ports and so on. And after that, you can choose the resource pool of providers. And after that, you can deploy. After deploy, you can connect to containers directly from asking AI agent, and it will show you some terminal. You can connect it, start, stop. You can check the logs and so on. And I think we can talk about some questions and so on. Yeah, let's see. What is the questions we have? Is it truly cheaper and faster? Why we and cloud providers offering? We have 3 tiers of providers. One tier for enterprise, one middle tier, and also community tier. On different levels, you can find different pricing. On top tier, we aggregate computer power from AWS, GCP, and so on from Asia. And on middle tiers, we aggregate computer power from micro data centers, and on the community level, it's public nodes, and it is the cheapest level. And if this is fast and secure, why we hasn't AWS and Azure copy it? Because we not compete with AWS. You can use it with AWS also, and in some days, obviously, a lot of we will have a lot of DevOps automation for AI agent box and so on. We debate production banking system on this today. If not, what is missing? Right now, we are working on a pilot with banking system. It's a neobank where it helps them for deploying initial version MVP and then updated. But with bank system, we are on early stage exploring what is missing. What we don't know on this step, but obviously we will need past a couple of steps on, and we will see. What is next? The demo show you tiny data size. Yep. For this demo, I show only show the super small config, and for our platform, you can add only labels for HTTP, HTTPS configuration for your domain name, DNS, and so on. And all the other stuff will be created by agent manually. We use Docker engine under the hood, and you need to create some typical compose for Dockers, and you can run any size of data that you can run in Docker. Only hardware under the hood is your limit. Okay, what's next? Is the ongoing project on blockchain on carbon tech? Probably it's from previous session. Yeah. Do you have some more questions? Is available with cloud native solution like Kubernetes. Right now, it's not available, but we are working on R&D stage for connecting kubectl. We have a runner, and runner can manage Kubernetes CLI also, but it's not for public tests yet. Your hash manifest on chain, isn't this expensive for large images? How do guys cast scale for Docker layer counts? We use own chain. We provide not only containers, we provide also upchains, and our public network work like an orchestration layer, and we plan to deploy some set of smart contracts for managing containers for other EVM networks. Right now, we're working with BNB, like our L1. And also, you can launch your app chain, and you can use the same agent. For example, you can ask, help me deploy blockchain, and it asks you some question, how many nodes do you need, and so on. And after that, it will create upchain NFT. It's like a certificate of ownership of this chain, and after that, you can mint some NFT nodes and register it for chain NFT, and it's like, as I say, certificates, and you can manage cost of your gas and so on. For container, we calculate time, uptime, I mean, and we plan to roll out several tariff plans, but right now you can pay for gas, like you can send your USDT, and it will be converted to gas tokens under the hood, and you can select the time of your container, 1 hour, week, months, year, what do you need, and you can top up this account with stable coins, for example. And we don't calculate Docker layers right now, but it's maybe an interesting idea. We'll see.
Are we at the Q&A session already? Dima, can you hear us well?
Yeah.
All right.
Here.
We're seeing your presentation right now. It says Real Code Zero Magic. Are we good to move on to the Q&A, or it's just me? Okay, now I can see your slides are moving. Right. So I've got some more questions for you, Dima. We've got the audience from We Are Community platform, not only from YouTube. If you don't mind, I'll read them out loud. Okay, so what they're saying is, simulate a 30% network slowdown. How does pricing adapt?
Okay, I see. We offer flexible pricing because, as I said, we have a free tier levels, and you can choose top providers like AWS, GCP, Azure, and our major focus on micro data centers right now. And micro data centers have a lot of hardware, but they can offer modern software services for public market. It's very expensive for for them to invest in this area, and we provide for them our platform and like a marketplace of computer power, but we use it like Airbnb about computer power. So exactly.
Thank you, Dima. I'll put some more on the screen.
How do gas function affect price predictability? What you pay and calculate when you sign manifest for container. You have a contract for this, and it's hasn't some fixed price and so on. The price is flat for time when container online and so on. And we don't use ETH for gas. And this Hoodway has our own token for gas, and usually we convert stable coins for gas payments under the hood. And the price is flat.
All right, we don't usually get that much of attention and comments here. I can see you have sparked an interest in our audience and you've got a lot of questions. And what I can say is that wishing you the best luck with your projects and future innovations. Dima, your work is truly paving the way to the next generation of blockchain infrastructure. Thank you so much. And yeah, Dima is a great friend of ours. He has been participating in our conference multiple times and has hosted brown bag sessions. Go check them out. And this one, it really does push the boundaries. And yeah, Dima, the best of luck. Thank you so much for being here with us today. I think we're good to wrap up at this point.
Thank you. Thank you for your time.
Thank you, Dima. All right, now we've got some time for the game, guys. You know, we have the whole engagement thing going on here on our Telegram chat. And before we move on to the next speaker, it's time for everyone to get involved with our quiz game. In a second, I'll share my screen. And you should be able to see the QR code for the participation in the quiz game. Here you go, guys. Test your knowledge, have fun, and win some amazing prizes. The first place gets the Netflix subscription, the second gets the Spotify Premium, and the third one gets the Amazon gift card. So this is the quiz game based on our 4 days of our conference. So yeah, do not cheat, do not use any GPTs, and scan the QR code on your screen to join our quiz game. And if you have any more questions, throw them in the chat or use our Telegram channel for the engagement. And yeah, guys, I'll have this on screen for 2 minutes or so. So yeah, hurry to scan the QR. All right, everyone. So we're about to start our quiz. Let me know if you were able to get the right link and participate at the quiz. You should be in the waiting room before I start the game. So if anyone is here with us, send a plus in the chat. It is your chance to win a Netflix subscription, Spotify Premium, or the Amazon gift card. The link for the quiz is in the chat. All right, I put the QR for you to make it easier. All right, we've got some people joining us, waiting for some more. Okay, I'll wait for 2 minutes. All right, I guess we're good to start. I see people spamming sub in the quiz dashboard. Anyways, let's go. All right, come on, guys. We're almost here. Everyone, just letting you know that 3 more minutes and we're wrapping up. So hard. Okay, guys, we're done. Let's see. All right, I can see that Rufina has got the first place, Jake got the second, and Alex got the third one. You can see your statistics here. Oh no, Scott, you almost got the fifth place. Anyways, Alexei and Bog, you can reach out to me as well. I've got some prizes for you as well. Where to claim them? I'll send my Telegram ID in the chat. All right. So to claim your rewards, reach out to me in DMs, and congratulations. Someone got the Netflix subscription from the first place. Jake got the Spotify Premium, and everyone else, you will be gifted with the Amazon gift cards for $20. How awesome is that? All right. Now, I think we can wait for a couple minutes, and upright, we've got a next speaker, Scott, who's a marketing specialist from New Orleans, focused on making crypto education accessible and impactful. How awesome is that? So yeah, guys, please be passionate, and we'll be back right soon. Okay, guys, we're here. The session about crypto education and mainstream adoption dives us into why clear communication and building trust are essentials for bridging the next billion users into Web3. And yeah, guys, if you're passionate about closing educational gaps and simplifying crypto for everyone when it's very needed, this talk is perfectly designed for you. Please join me in welcoming Scott.
Hey, welcome. Thanks for having me.
Yeah, good morning, Scott. And the stage is yours.
Good morning. I appreciate it. Yeah, so exciting things. I actually was part of this program 2 years ago. So I spoke on mainstream adoption for Bitcoin or Blockchain Professionals Day in 2023. So what I did was I kind of took that previous presentation and kind of look back at it and see, hey, where have we come in the last 2 years as far as like where do we also need to go? A little bit about me. I started in like the hospitality, tourism, food and beverage industry, and then transitioned into marketing and marketing agency, social media type work. And now I've been full-time crypto for probably 4 to 5 years now. And do a lot of marketing consulting and worked with a lot of different projects. So I have a unique client-facing perspective of adoption and onboarding people into crypto. And while some of the presentations y'all have had are amazing of the tech behind it, but I think we have this learning gap, this bridge between this ever evolving technology and what this technology can do, but how does it fit the day-to-day average person, and how do we get to that point where the adoption and day-to-day use of crypto, blockchain, Web3, all these wonderful technologies. So I'm going to just jump right in. As far as like what is it we're actually like how are we actually going to define this, and kind of an overview of what we'll talk about. So I use the word we in this title, the introduction discussion of we as challenges and how we overcome them. Because I do believe it's everyone's job in crypto to help onboard like you said, the next billion users into crypto. it's our job. If you're working in crypto, I think part of your job is marketing. Everyone's in sales, everyone's in marketing. And then what is mainstream adoption? How do we define it? What are those challenges and how we can overcome them? Mainstream adoption, a lot of people define it as when you're using a technology and you don't even understand or realize that you're using that technology. A lot of people define that as mainstream adoption. So moving on here, when you look at mainstream adoption just in general, not specific to blockchain or crypto, you see these bell curves in this adoption cycle, and you could compare this to technologies from say 100 years ago, running water, electricity, automobiles, to cell phones, the internet, those type things, and obviously these technologies are adopted a lot quicker than when because of the other technologies. And then if you look at the bell curve of adoptions, you've got the innovators and early adopters, also kind of like a bleeding edge or a cutting edge, and you've got people that just love new technologies and they want to be the beta testers. They want to be out front. And then you got some people, especially with generational and age gaps, that they don't learn technologies as quick, and they want to wait. They don't want to beta test. They want to wait for a fully fledged project or that is easy for them to use. You got people that didn't get an iPhone when it first came out. They waited for the next generation and for everyone else to learn and figure those things out. And then what does mainstream adoption for crypto even mean? Does that mean being able to pay your rent in crypto, or does that mean being able to pay your mortgage in crypto? Or the gentleman had the talk earlier this morning, like, why can't we pay for a cup of coffee with crypto yet? So how we define mainstream adoption, if you ask 10 different people, they'd probably give you 10 different answers. But basically, we want to make it easier. We want to make it easier for the average person to use crypto. Is that using Ripple for cross-border payments or stablecoin for cross-border payments instead of the traditional SWIFT network, to where you're waiting 5 to 7 days and paying 3 to 5 middlemen, as opposed to one transaction that you have your money in a matter of seconds or a minute. So as we move, so this is another. So the graphic on the left is from my 2023 presentation. The graphic on the right is a newer one. So you can see the adoption based on different continents or different parts of the world, and that can be accredited to a lot of different things, including regulation or traditional banking and access to traditional banking, or people that do not typically have access to traditional banking, and they're more prone to start using crypto in their day-to-day life. So again, but we're still at that 5 to 15% is the estimate of the world's population that's holding crypto. However, if you think about it, that's a really difficult number to pin down, because how many wallets can one person have? So if you're tracking it based on the number of Ethereum wallets that have been created, or the number of users that are holding this, or is it just survey data? So I think there is a lot of opportunity for deviation in that range of how many people in the world actually own crypto. And now with ETFs and other things like that, then are you owning it in an actual DeFi wallet, or are you owning it in cold storage, or are you owning it as part of an ETF or something like that? So it really depends on, I guess it's hard to pin down what an exact number is for that. But I think we can all agree we're in the 5 to 15% range if you look at global. And then if you go back to this chart and compare it to this chart, that puts us in that early adopter stage, trying to make the jump to early majority. And so then what's fun is if you look at these traits, and I just found these online. I didn't come up with this, but traits that accompany or go along with those different adoption groups. And the early adopter traits are people that are willing to work through early bugs, right? Those are people that enjoy being a part of a beta program, or people that want to have something new because they want to be known as the person, that always has new technology, as opposed to that next big step, like the early majority. They're more practical. They're like, okay, well, why do I have to set up all these seed phrases, or why do I need to do this? Why? So they're more data driven and logical, and not wanting to try new things. So it kind of does. That's a big jump to go from the early adopters to the early majority. One fun thing. So I travel for work a lot, seeing clients. And one thing I like to do is when I'm in airports and traveling, I like to wear different crypto themed t-shirts or clothing. And one thing I've been doing this for a couple of years, and I notice when, like, over time, people's reactions to my shirt is kind of like an unofficial market sentiment. So some of them these are kind of comical versions. So this is a shirt I like to wear, and obviously it's a joke. I am Satoshi Nakamoto, right? So wearing that shirt in an airport, the people that see your shirt, and you can see people see the shirt and they look at you with a question mark in their head, and they're like, what does that even mean? Versus people that see the shirt and laugh and give me kind of like a thumbs up across the terminal. I'm like, okay, so as like a market sentiment thing over time, how many people react to my shirt that way? How many people think it's funny? And that's my own little market sentiment of adoption. And I got one other one here I'll share is my mom thinks I work at Bitcoin. So again, it's kind of a joke because nobody works at Bitcoin, right? But my mom thinks I work at Bitcoin. And when I wear that shirt in public, or when I wear that shirt in an airport, and I'm able to judge people's reaction, is my own kind of litmus test of where are we on the adoption scale. And then here we are with the challenges, right? So I'll talk through these real quick. The regulation clarity, FUD, fear, uncertainty, and doubt, overcomplication, and bad actors. And with bad actors, I throw in a bunch of other different things. So FUD is not new. This is one of my favorite slides in any presentation I do. So these are old cartoons creating FUD about other technologies that have come along. Hat tip to Dan Held on LinkedIn is where I first came across some of these graphics. And then, the Pessimist Archive, I believe is what it's called on Twitter. I've got the link right there. Is sharing these older examples of FUD against the anti-electricity. There's another story I love to tell, that there's a anti-automobile farmers association in Pennsylvania about 100 years ago. And they were trying to pass laws against the automobile industry. And they had a law proposed that if you're in an automobile and you're coming down this side of the road and there's someone on a horse coming on this side of the road, if you're in the automobile, you had to pull over on the side of the road, and you had to have a natural colored tarp, and you had to cover your car with the tarp so the horse wouldn't get scared. And then if the horse still wouldn't pass you, you had to take your car apart and hide the car parts in the trees. So obviously we know, like, taking a car apart, covering a car with a tarp, but that was FUD of its day. So FUD is not new. Right. But that is a challenge. Overcomplication. So I think about this a lot, and I deal with a lot of people because I help a lot of people onboard into crypto, into blockchain. And a lot of the terminology it's like it's a barrier to entry for a lot of people. And then moving along is challenges. I'd say bad actors. So bad actors, I think, is a massive category. And how all that, fits in, like, what are bad actors? But all these are, hurdles to mainstream adoption. From pump.fun and people, the crypto Twitter saying XRP is going to be at 1,000 per token. I mean, I could look at the tokenomics, and I mean, that'd be incredible. But like the tokenomics and comparing the market cap of XRP going to 1,000 is pretty wild. And then you've got like I've shared a screenshot right there of a phishing text I got. And then obviously SBF, and then the celebrity meme coin circus. All these, in my opinion, are challenges to mainstream adoption, because a lot of people that are, we can call them normies or whatever you want to call them, that have never been exposed to crypto. Unfortunately, these are some of the first instances that they have exposure to crypto, and they have a bad experience. And some people joke around. I've even made the joke that that's a rite of passage for someone new coming into crypto. But it could also be a reason for them to create FUD or to not want to get ever involved in crypto ever again. So again, these are challenges. All right, so let's pivot to solutions. Everybody knows Bitcoin Pizza Day. So Bitcoin Pizza Day was the first transaction of a real life good for Bitcoin. In the Bitcoin Talk forum, somebody posted, "Hey, I want to swap Bitcoin for a pizza." We all know the story, right? Okay, so in 2023, what I did was it was a Papa John's pizza that was used in Bitcoin Pizza Day. I went to all the major pizza outlets' Twitter account, and I said, I wonder if any of them have said anything about Bitcoin Pizza Day on their Twitter. Know that Papa John's, like, we're all talking about it, right? In 2023, not a single major pizza chain did anything about Bitcoin Pizza Day. Papa John's didn't even tweet on that day. Okay, fast forward to this year. Not only did Papa John's tweet and use the Bitcoin Pizza Day hashtag and make multiple jokes about Bitcoin Pizza Day, they also ran a contest, a promo, in the original forum that Bitcoin Pizza Day, the transaction, the barter was made. So in my opinion, that, like, from a marketer, right, that is not adoption, right? That is not mainstream adoption. However, it is a step. It is a step that now these major brands are talking about what could be called a holiday or a main event that is an annual occurrence in the Bitcoin crypto blockchain world. But the fact that they did the promo inside the forum, I thought was fantastic. And it shows just in a couple years, in 2 years from them not talking about it at all to them doing a promo, using the hashtag, making multiple jokes, I think is a nice step in the right direction for that adoption. And then let's talk about, regulations. So the United States, just in the new administration, just in the last couple of months, has made a lot of announcements with different organizations and agencies within the United States government to start clearing a path for crypto adoption within traditional finance. So obviously you've got the ETFs that rolled out, the Bitcoin ETFs and different opportunities for traditional financial vehicles to incorporate crypto. So like I said, like Bitcoin ETFs, there's other crypto ETFs, there's a lot more being proposed. So that was kind of the first step. Now you've got the FDIC and the OCC, which are the government agencies in the United States that manage most traditional banks, are removing the blockers of previous administrations and are making it to where it's easier for traditional banks to interact with crypto. And then the one on the top is exciting. The Department of Labor, which manages retirement plans in the United States, is removing blockers to where retirement plans could interact and hold crypto as well. So again, these are the foundational steps that need to take. I'm not saying that these traditional banks now have to use crypto or have to interact with crypto, but the fact that from a regulatory place that they could, again, it's like Papa John's tweeting hashtag Bitcoin Pizza Day. It's not like Papa John's is going to accept Bitcoin in their stores tomorrow, but is a step in the right direction. And it's these baby steps that are going to get us where we need to go as an industry. And again, I just mentioned the ETFs and retirement plans accepting crypto. So again, the BlackRock Bitcoin ETF, and I know a lot of crypto purists or DeFi purists or Bitcoin purists do not like ETFs and do not like the fact that BlackRock is getting into Bitcoin or has been in Bitcoin. The same thing with Fidelity. But there's a trade-off, in my opinion, between purist and adoption, and those kind of need to work together. It's like Bitcoin maxis, right? Like, I'm not saying they're wrong on everything, but also that's not, in my opinion, I think that's infighting with the crypto industry it's not conducive for mainstream adoption and moving forward as an industry. All right, so simplification. Again, a minute ago, we talked about terminology and how I think some terminology is a barrier to entry for different people that are not necessarily have a tech background but want to get involved in crypto. And a lot of the terminology itself is a barrier to entry for them. And I think, a lot of crypto-based companies, blockchain-based companies, I think it's our role or our responsibility to provide, maybe it's blogs or onboarding modules or glossaries of terms, or like ABCs of Web3, right? Like, what is a gas fee? I always pick on gas fee. Like, why do we have to call it a gas fee? Because that's the term that most people outside of the industry are not familiar with, as opposed to just a network fee or a transaction fee. How many people would be completely fine paying if on their billing statement they see network fee or transaction fee, and they're used to paying that? But when they see gas fee, it's in my opinion, overcomplicating a term. So on the screen, I've got a screenshot from YouTube. This is a great little 3 to 5 minute cartoonized version explaining Bitcoin that I share this with a lot of people. And I think more tools like this, more platforms. Another one I love is Whiteboard Crypto on YouTube. And it's a great way to just, simplify a lot of crypto language, simplify a lot of heavy crypto terms or concepts that make it easier for this adoption and onboarding of the next 1 billion people. So I'm not sure exactly who did this, but this was a thing I stole from LinkedIn, where someone took a lot of crypto terms, blockchain terms, and just, dumbed them down, for lack of a better word, into super, super easy to understand, easy to use terminology. Gas equals transaction fee, consensus equals agreement, token equals digital item, right? Just making it easy for people, making it easy for new people coming in to understand. Another thing I like to do is try to put either through visual examples or analogies, explaining technical things with non-technical analogies, or using Web 1 and Web 2 terms to compare and draw similarities with Web 3 concepts. And I think when you're onboarding people, that makes things a lot easier to. And when you were talking about mainstream adoption, I think education is a huge component of that, and just bringing people in a way that they can understand it. One of my favorite analogies is, and this is a picture from The Sandlot, one of my favorite movies growing up about baseball. Okay, so if you look at a playground sports game, just a bunch of kids showing up and they're going to play a game. Maybe it's soccer, maybe it's baseball, whatever, maybe it's basketball. Those kids that show up, right, they know what game they're about to play. They know the rules they're about to play, and they're going to keep score amongst themselves, right? Okay, use that bunch of kids playing a game to compare blockchain, okay? There's no referee, meaning it's decentralized. If there was a referee, that would be central authority. Okay. all those kids understand the rules of soccer, right? And they all understand that's consensus. They understand the rules of the game they're about to play. The distributed ledgers, everybody's keeping the score themselves. So if you've got 10 kids out there playing 5-on-5 and 9 of them say the score is this and 1 kid says the score is this, the 9 is going to win, you know? So that's the distributed ledger in action forming consensus. And that 1 kid can't change the score. Obviously, this is not a 100% applicable analogy, but when you're talking about trying to explain a very difficult concept to someone that is brand new to this, I think using analogies like this are very helpful when onboarding the next 1 billion people. And tools like this are, I think, what is going to get us there. And when you talk about, I say everybody in crypto's job is you know, teaching and education and onboarding. And a lot of people might say, no, my job is this. I'm a back-end guy. I'm a developer. I'm not dealing with that. Well, if you think about Bitcoin, right? So like Bitcoin is where it is because of the community. Not like Bitcoin does not have a marketing team. Bitcoin, you know, does not have a paid social media team. Bitcoin doesn't even have social media accounts. It was the job of the community. The Bitcoin community got Bitcoin where it is today. And if you're looking at education, there's also a lot of education around traditional finance. And I think one of the hurdles of DeFi is that a lot of people don't even understand traditional finance. A lot of people do not even understand fiat. So a lot of people do not understand, you know, the way that traditional financial markets work. So then they don't always understand the problems and issues with traditional financial markets to see how decentralized finance and DeFi and crypto and blockchain and all these things can actually help solve the problems if they don't understand the problems in the first place. Also, safety and security. I always enjoy this little meme, you know, but onboarding people, when we're onboarding people in a safe and secure way and explaining to them why we do things the way we do. If you explain to people the difference between custodial and non-custodial wallets, and then explain why seed phrases exist the way they do, it makes it a little easier. And then, you know, teaching people, hey, here's some best practices for password management, and here's how to make sure you store these, you know, but teaching that as we onboard people. I've heard it described that, you know, everybody remembers, I think, or I know I do. Everybody remembers when they got their first crypto and they were first brought into crypto, and they remember that hurdle, right? In that learning curve, and someone else had to bring them in. And I've been told that's like a trauma bond, right? Like you're bonded in trauma with the person that brought you into crypto, and you remember that. And you know, but now you've understand that hurdle, and you want to you're either not going to want to do it at all, or you're going to want to make it easier for the next person you bring in. And that's why I think it's all of our job to do this. And also, like, you know, when I talk to people about crypto and blockchain, you know, I'm putting in the right mindset. I'm not putting it in, you know, it's more like, hey, here's some real world applications. Here's some problems with the world today. And here's how I think blockchain and emerging technology can solve those problems, as opposed to we're going to get Lambos, right? And I think a lot of the people coming into crypto are worried about when they're going to get the Lambo, as opposed to what can the technology do that previous technology has not been able to do, or what can blockchain do that previous centralized industries and centralized communities have had hurdles with, that a decentralized community or decentralized technology through blockchain can do better to make a better world for the future, as opposed to all of us getting our Lambos. So thank you all for having me again. I enjoy this. I look forward to it, and the community interacting together in the Telegram game and everything. So again, there's my LinkedIn. That's the best way to follow me and interact. I talk a lot about crypto as well as social media trends and different things like that. I saw some questions in the chat, so happy to hop over there.
Right. I'll be displaying them on the stage
Okay,
in a
great.
minute. And before that, yes, thank you so much, Scott. I mean, I think your lecture should be taught in schools, honestly. It was amazing.
Well, thank you.
Oh, my bad. I'm sorry. So I've got some questions from my side for you. Why do you think, why do so many scams happen in crypto compared to regular banking? Well, I think the question is what makes crypto attractive to bad actors? Or you think it's one of those, logical fallacies? Like,
I think, number one, I just think it's a new technology. And it's kind of the Wild West. But I think like all new technologies, until like people understand and learn and have that, adoption, they don't know how to protect themselves, but there's no, I think bad actors are everywhere. I'll also say that, like, there are bad actors in traditional finance. There are bad actors everywhere. There are scammers everywhere. I showed the scam phishing text I got about a Coinbase account. Well, I also get those about my Amazon account. So I do think bad actors are everywhere. There was a thing a couple years ago about how, most drug dealers and terrorist organizations use crypto. Well, most of them actually use the US dollar. so I mean, I think it's more visible, and it's easier to fall prey to them because people are uneducated, and people do say, so one example is when the Trump coin came out back in January. Within an hour, 2 hours, on Dex trending, on like Dex Screener or Dex Tools, all of them, there were 40 to 50 Trump coins, because you can make coins so easily. So it is a new technology, and so you've got all these new people coming into crypto, and all they know is, I need to buy the Trump coin. But you've got all these people in crypto that are like, well, I'm going to launch my own Trump coin. And it's just, the technology is so fast. But I think education can solve that. Like, people being more educated. Like, I used that when that happened. I used that as an opportunity to teach my community about contract addresses and make sure you have the right token contract address, as opposed to just searching for the name of a token.
Right. Yeah. As you claimed, I suppose that, the education is something that stops the bad actors, right? But who else do you think can stop the bad actors in crypto if there's no bank or government watching over them?
I think one thing that is difficult when you talk about, like, why is crypto so prone to bad actors as well, is because of the international element, cross borders. And so if one country creates some regulation, that's fantastic for that country, but that doesn't necessarily protect the citizens of that country from a scammer coming from a different country. So I do think it's the role of the community. I think it's, I think it comes back to education. And I also think a lot of it, there's some self-responsibility. If I'm new coming in and somebody tells me about some meme coin, and I'm like, cool, I want to do this, I need some self-responsibility to not just trust the world. I need to do the research on it before I put $10,000 into this meme coin that I know nothing about. I kind of feel like that's my fault. right? Like as adults, I think there's some self-responsibility to do your own research instead of like trusting your college roommate who texts you. He's like, dude, you need to buy this meme coin. Put everything you got in it. Let's be adults.
Of course, yeah. 99% of altcoins fail within months, and unfortunately, that's something that is hidden, right?
Yeah, you're coming in. You're someone else's exit liquidity. There's no utility for that token. There's no project. There's no roadmap. There's no real world application. It's a funny picture of an animal doing something funny, and they made it in a token and told everybody they're going to get rich. But the only people that get rich are the devs or the inside team, and they're wanting everybody to come in and be their exit liquidity. And it repeats and it repeats and it repeats. So again, I think there's some self-accountability, and to be a responsible investor as an adult to research what you're coming into. But unfortunately, that doesn't happen. And then crypto as an industry gets labeled as the bad actor because someone didn't do their own research.
Right. People FOMO into scams because they only see the winners.
Yeah.
Right? And I think we can take some questions from the audience now, Scott. Here they are.
I think El Salvador. So El Salvador's Bitcoin experiment mainstream. I think it's a good proof of concept for other countries. Now it's proved to be like if you call it a success or not, like that, I think that depends on who you ask. But now you see other countries that have, I believe there's towns in Switzerland, different countries are accepting Bitcoin. There are different states in the United States that are now having strategic Bitcoin reserves. So I do believe that it's an option because I think adoption is a multifaceted thing. You've got the users, but you've also got the countries and the regulatory and the organizational level. So I do think it's a step. Again, back to I got excited that Papa John's tweeted about Bitcoin. So I think all these are steps, and all of these added together, help us get where we're going. So CBDCs. So I think, to some that's controversial. But I do think if you wanted to skip, referencing the technology adoption chart of late majority, I think, that could be because, like I said, the screenshots of the OCC, the FDIC, just paving the way for traditional banks, especially in the United States. I know there's, a lot of other countries represented here. But the fact that regulatory that the banks can use and can interact in crypto, I do think all different types will help. One of the challenges, though, I do think is traditional banks, they make a lot of money by doing things the traditional ways. So I think just traditional banks adopting this technology themselves might not be in their own best interest financially. It might be in the best interest of their customers. So we didn't really even talk about that, but like Swift, say Swift versus Ripple, right? So Swift is a co-op owned by banks. So even though Ripple might be faster and cheaper for the customer, do the banks actually want cheaper for the customer because that's less money for the banks? So there's some conflicts of interest there that we'll have to watch and see how it plays out. All right, MetaMask has 30 million users, but still confuses normies, 100%. Should we abandon wallet self-custody for mainstream adoption? I think this depends on the person, right? Like if I'm helping a friend, get into crypto, and they're not a tech person, right? And I know this would overwhelm them. I might suggest they just buy a Bitcoin ETF as their introduction to Bitcoin, right? Or their introduction to crypto. I'm like, hey, look, you already have an account with a broker that you could buy an ETF. That should, if you think about the swimming pool, that should be their shallow end of their pool. That should be them dipping their toes in the pool. But if I have a friend that's a developer or a tech guy or adopts things quickly, I'm going to say, hey, man, like we need to skip a couple steps, right? I do think, and also like, so usually when I onboard a friend or someone asks me, I usually have them start with a centralized exchange, you know, because it is more user friendly. Like if they don't need to hold their seed phrases, and I just have them start there to buy something. But I know not every country has that luxury, you know. But I think it depends on the person, you know, and if you're depending on the concepts, you can overwhelm some people. But also when you talk about crypto purist, you know, self-custody is kind of the root of blockchain, of crypto. Self-custody is the whole reason we're doing this, you know, to be able to control your own assets. So I'd hate to just say we're going to abandon that for mainstream adoption. It kind of defeats the purpose. But I do think MetaMask and some, you know, pretty much anything DeFi or DEX trading, all of those they do have a lot of hurdles, and it's an uphill educational curve. We really didn't even talk about this, but I don't think that crypto, if you look at the internet, a lot of people compare crypto to the internet and their growth, and they say that crypto right now is the internet in 1993 or 1994. So by looking at that, crypto still has not had its AOL disk moment. AOL was like sent out those disks, right? And that was the adoption jump for the internet, making the internet easy for everybody to get into. And I don't know that crypto has had that moment yet, but I would hate to say we're going to abandon self-custody. You know, maybe MetaMask, I know they're always working on things. Maybe they just need to have an AOL disk moment version of MetaMask to help onboard people.
Thank you so much, Scott. Yeah, and in general, thank you for that amazing session, really, on that highlighting the role of education and bridging the crypto to the mainstream. Honestly, again, as I said, this kind of talk that it should be taught in schools. And yeah, I'll personally reach out to you for the collaboration if you don't mind. So
yeah, absolutely.
Thank you, Scott, again. And unfortunately, hate to say this, but this wraps up the day 4 of our Blockchain Community Day 2025. And huge thanks to you, Scott, to all our incredible speakers, attendees, and everyone who made this day such a success. Right. See you, Scott.
Thank you.
And yeah, I'll reach out. Before we go, don't forget to stay connected with us on our Telegram chat. And yeah, everyone who won a reward on our little interactive games, reach out to me directly. And yeah, join our Telegram chat for ongoing conversations, networking, and more fun stuff. We'll see you tomorrow for another, and unfortunately, the last day of our conference. And yeah, it's going to be full of cutting edge technologies, insights, and innovations. Have a great evening, you all. See you.